Good afternoon, sir.
Yeah,
Shall
good
we,
afternoon.
shall we start,
Yes.
sir?
Yeah, please go ahead. Yeah.
Thank you, sir. Dear sir, madam, so we are in the sixth day of online ATAL 6-day faculty development program. The title Design for Manufacturing and Advanced Automation for Industry 4.0. Today, 11th session, we have renowned resource person, Dr. N. Selvaganesen, sir, Professor and Head, Department of Avionics, Indian Institute of Space Science and Technology, Thiruvananthapuram, Kerala. So, in this August occasion, I would like to invite Dr. D. Savaraj, Associate Professor, Department of Technology, to introduce our resource person to the participants.
Thank you, Raja sir. This is my pleasure to introduce our resource person, Dr. N. Selvaganesen sir. He is a distinguished academic and researcher, currently serving as professor and head of the Department of Avionics at the Indian Institute of Space Science and Technology. With over 2 decades of experience in academia, Dr. Selvaganesen sir is an expert in adaptive control, fraction order modeling, and psychological system modeling. He holds a PhD in adaptive control from MIT campus, Anna University, and ME in control system from PSG College of Technology, and B in EEE from MEPCO Shelley Engineering College. Dr. Selvaganesen sir has held esteemed academic roles as assistant professor, associate professor, and professor at IAST, and has led the Department of Avionics as his heads of 2 separate occasions. His leadership has been instrumental in advancing several key research projects and academic initiatives. His research contribution in the field of adaptive control, particularly in fraction order modeling and control, have been widely recognized. Sir dedicated a mentor, and he has supervised several PhD scholars whose research has been published in top-tier journals and presented at international conferences. He himself has published extensively in prestigious journals such as IEEE Control Systems Letters, IETE journals, and measurement control, with his recent work focusing on robust adaptive control and cardiovascular system modeling and optimal tuning of fraction order controllers. Dr. Selvaganesen sir expertise and leadership have earned him several accolades, including the Best Paper Award from the Journal of Education, IETE. He is a senior member of IEEE and a life member of SSI, Indian Society of Technical Education, and Indian Society of System for Science and Engineering. So we are honored to have him with us today, and I am confident that his insights greatly enrich our faculty development program. Welcome, you, sir. I hand over the session to sir.
Yeah, thank you. Can you hear me?
Yes, sir. You can share.
Okay. Thank you. I hope my screen is visible, right?
Yeah, it's loading, sir.
Okay.
Yes, sir. Yes, sir. It is visible, sir.
Okay. Okay. Thank you. Thank you, Dr. Raja and your team for inviting me for giving a presentation, something maybe interesting topic related to limit cycle prediction for system with nonlinearity. So I directly go to the topic of interest, and many of the industries, we normally what we do is we as a control system engineer, we try to design a controller. So when you design a controller, and we normally look for the plant characteristics, right? So the plant characteristics in general, it can be a linear or can be a non-linear, right? There are this is the class, general class, linear and non-linear, and in the non-linear system, we are in this presentation we are exclusively talking about some systems comes with non-linearity, hard non-linearity, which can be characterized separately, and based on such non-linearities, one can perform a control system design. So the major challenge with respect to nonlinearity in the plant when you want to design a controller is limit cycle behavior. So we are trying to understand in this presentation we are trying to understand how limit cycle can be predicted, maybe present determined for such systems. Comes with nonlinearities. This is the objective of this presentation. We are going to talk about some introduction about nonlinearity, and then we would like to see how the nonlinearity can be analyzed through describing function. And here, for case study, we are considering three nonlinearities. One is on-off nonlinearity, and then relay with the dead zone. These two are a simple nonlinearity which we considered, and another nonlinearity is backlash nonlinearity, which we are seeing actually in practical case. All these nonlinearities basically seen from or visualized from the practical systems of plan. Then we also discuss about different stability methods, because we would like to understand whether the limit cycle introduces whether the nonlinearity introduces stable limit cycle or unstable limit cycle. So we are trying to see how that stability can be enhanced. And at the end of this presentation, we would like to see that how different systems, something like system comes with relay and dead zone, how it is done. And we also consider system like servo systems comes with backlash. Maybe the backlash basically comes from the gears mechanical system. How this is handled actually by means of control designs. But here we are not going to focus more on control system design. We are going to focus more on how that limit cycle can be predicted. So, because if you consider control system design, maybe it requires maybe 5 to 10 hours time. Normally we take 10 to 15 hours time for this topic. So here I'm going to simply introduce how these can be determined. As all of you know, this if you look the properties of the linear system, suppose if you say exotically X, right, has basically as a unique equilibrium point if A inverse exists. Suppose if A inverse doesn't exist, so normally what we do actually, so it basically provides you or inform you that infinite number of equilibrium points. There are more than one equilibrium point. This is what that we say that the system is not linear. And also we are talking about the equilibrium points are stable with respect to initial conditions and in the presence of external input, that is your key. And normally what we see from the linear system theory is we apply simple superposition theorem, where we see here we check additivity and homogeneity. So by giving input x1, it provides y1, and by changing the magnitude to x2, that system provides you y2. It goes like this, and some of these two inputs supposed to provide some of these two inputs. This is basically additivity property, and then the homogeneity property, and that provides you just by adding a constant multiplying a constant with this input alpha times x1 plus x2, that provides you alpha times y1 plus y2. This actually explains you the superposition theorem, which we learned from control theory, basic control theory. And another type of stability is asymptotic stability. So basically, stability aspects, notion of stability is two things. One is bounded input gives bounded output, and second one is asymptotic stability. So basically, control engineers, normally we see asymptotic stability is the superset of stability, because if the system is asymptotically stable, it is Bibo stable. But other way around is not true actually. When the system is Bibo stable, it need not be asymptotically stable. So we always try to check the asymptotic stability of the system here. And also, we are seeing that the sinusoidal input always provides you sinusoidal output in case of linear systems. So these all of you are there. On the other hand, the properties of nonlinear systems, if you look at the stability perspective, a nonlinear system may converge or diverge depending on the initial conditions as well as input. Depending on the even small change in input or small variation in initial conditions, you may get into large variation outputs and so on. So the convergence and if you look at the stability, convergence and divergence basically decided by the initial conditions. So there is no guarantee for say that for the given system, for the given initial condition, the system is stable. So that need to be experienced. So this is the basic behavior with respect to stability. And also we know sinusoidal input always leads to non-sinusoidal input. And particularly we explain the concept call it as limit cycle. This is what we are going to discuss in this complete presentation. The limit cycle is basically defined as follows. So your output basically provides some output, provides fixed amplitude and fixed frequency. So without any external excitation, we normally term as limit cycle. So you might have seen when you talk about designs, control system after control system design, your output may perform some oscillations that you might have observed actually in some simulations when something, nonlinearity or some nonlinear systems are built with when you do some design problems. So this basically we call it as limit cycle. So we are trying to how that control system, how it avoids the limit cycle is another category of problem. And here we are trying to focus or see how the limit cycle first of all can be predicted, because this predicted information is useful for design of controllers. But the biggest problem with respect to dealing with nonlinear systems is Laplace and Fourier transform cannot be applied. This is what the first part of this, and it is difficult to analyze analytically and understand the complexity because since the system comes with nonlinear elements and nonlinear components. And analysis in case of nonlinear systems basically done to find the solution of nonlinear differential equation with specific input and initial condition. That's what we cannot, because different input and initial conditions will change. So normally analysis will be done with respect to the particular input and particular output, or listing of input and output. And also no universal analytical methods exist to analyze the effect of nonlinearity. So these are all some of the issues just from the literature. And there are many methods for analyzing such nonlinearities. So the methods are describing function analysis and phase plane analysis and Lyapunov stability analysis. So if you look at Nagarothan Gopal textbook, Control System Engineering by M. Gopal or Nagarothan Gopal, or Digital Control System by Nagarothan, we can see this methods, introduction of these methods, describing function, phase plane analysis, and Lyapunov methods analysis. Some of you may be experienced in these methods. Here, we are going to express only about how these nonlinearities are modeled by using describing function method. Like your models, your physical systems, we normally represent in terms of transfer functions. Some of these we do using state space and so on. So here, similarly, we are dealing the nonlinearity by using describing function for representing the models. Let us have an example here, and this example shows this restaurant plate dispenser, and if you model it, it comes with some mass, with spring plates are basically mass, and it added to the spring here, so that it will this is oscillatory behavior. So in order to avoid oscillatory behavior, normally we use actually so that when you take the plate out, one plate out, automatically it will come, the next plate come to the first stage of this. So this will happen. So if you want to make a model of such systems, it will be something like mass spring damper system. What you see actually from control theory. So these are all you studied. So normally we assume these are all linear. Under this assumption, we write the expression mx double dot plus bx dot plus k times x, that is equal to f of t. This is what normally we write. But if you look at this wonderful equations, we studied something during your 11th standard or 12th standard, these wonderful equations in physics. So they are introducing nonlinearity with respect to the friction. So if you look at the equation my double dot, so y is the output here, consider here instead of x, and y double dot plus friction, we are introducing b times y square minus 1 y dot. Normally we consider b times y dot when you do in fact classroom approach, or when you deal with linear systems. But here, since we are considering a nonlinearity introduced by friction, so we are using wonderful uses b times y square minus 1 times y dot plus k times y equals 0. We are assuming all variables greater than 0, and here, if you look at this here, when you say that for large value of y, so how this introduces this oscillatory behavior, what is shown, what you see in the left side of the graph. So this is basically large value of y, the system motion has converged tendency, and smaller value of y, if you have value of y is very small, the motion tries to diverge. So this basically introduces oscillatory behavior in the system. So the system motions can be either it can go to grow unboundedly or decay to zero. So it is basically restricted to some magnitude that actually provides the oscillatory behavior of the system, and it displays. We normally say that sustained oscillation and of the system with independent of initial conditions. So this is the simple example where we see the limit cycle in the systems. If you look at the linear system, sustained oscillation basically introduces when. So sustained oscillation basically introduces if the poles are lying on the imaginary axis. So if poles are lying on the imaginary axis, we normally say that the system is marginally stable. So that introduces oscillatory behavior. If you look at the nonlinear systems, the limit cycle amplitude is basically independent of initial conditions, and limit cycles are not easily affected by system parameter variations. Even small variation in parameters, it do not affect the limit cycle behavior. Also, nonlinear systems with periodic inputs may exhibit a periodic output whose frequency either a subharmonics or harmonic frequency. And another important application, what you see in the right-hand side of the figure, is jump response. This is basically seen from rudder systems, maybe ship sailing systems or aircraft systems. So this is a very complex problem actually in aircraft systems and maybe ship systems. So when you want to use because this rudders actually basically introduces some kind of nonlinearity. What you see here, this is output y and with respect to frequency w omega, and when you just charge from frequency, small frequency to large frequency, the response goes like this, and it goes like this. Okay, during your loading condition, when you are increasing the frequency from zero to minimum to maximum, when you are decreasing frequency from maximum to minimum, so the trend supposed to be goes like this and like this. But that's not happen actually in the system here. So basically what happens here is in the rudder system. So that's what the conventional discussion. So this rudder systems, basically what happens is when you're loading the frequency, so from omega, increasing the frequency from minimum to maximum, after B1, it will not reach B2. It directly jump to here and it will come here. And when you are reducing the frequency, it goes to B2 and then it jumps here instead of coming to B1. So you can understand this. There is a gap. There's a jump actually in response. That's why we call this response jump response. So this is very peculiar actually in due to nonlinearities present in the systems. One example of what you see here is a rudder systems. And you look at other methods as available in the literature from maybe basic textbooks like control systems or digital control systems, MCOVAL or not MCOVAL, and you can see graphical display of system motions. Normally they use two-dimensional things actually, phase plane, because suppose if you have higher order systems, you need to convert maybe to second order dynamics and just you have to apply this phase plane system. And but this is not approximation method, it's actual method. But the only limitation is that conversion, because you need to reduce from higher order to second order dynamics. And this is applicable for both hard nonlinearities and soft nonlinearities. We are talking about hard nonlinearities in this presentation. And on the other hand, Lightning method also there. This is also applicable for both hard nonlinearities and soft nonlinearities. And but this is applicable for higher order systems as well. But the limitation is, when you deal with Lightning systems, Lightning stability, normally we need to create a function. So it is basically difficult to create a function for function for such systems. Even it is much more complex when you start dealing with control system design, because normally we experience these kind of problems when we deal with adaptive controls. Because adaptive controls, in specific model reference adaptive control, we normally deal with Lightning method of obtaining the control tuning. So much more complex maybe when you deal with that. Even linear system, it is complex. When we talk about nonlinear system, definitely it's much more complex. So these are all some of the limitations actually when you deal with this phase plane analysis, maybe under Lightning stability analysis. Here we are talking about describing function analysis. This is basically we are dealing with hard nonlinearities like saturation, backlash, and whatever the physical nonlinearities which are there, and we are converting into mathematical model in the form of describing function. And we are doing the analysis for predicting the limit cycle frequencies and magnitude. So here what's happening here is we are just separating the plant into two parts. So one is linear part and second one is non-linear part. And this actually then the nonlinear part we are using discriminating function for writing the equivalent mathematics, and based on the discriminating function one can able to do the analysis. So this basically called as linear approximation, and or we call it as harmonic linearization, because the nonlinearity is there, we are representing in the form of linear, like nonlinear system is there, we are writing the linear equation just by approximating it, right, using Taylor series expansion and so on. So similarly, we are doing here the nonlinearity is there, and how the nonlinearity is represented in the form of a function. So using harmonic linearization. So, but the major problem with respect to this is there is an assumption always we make. You are close to dynamics to provide you the low pass filtering action. So this low pass filtering action basically inform you that the prediction is better. If you say that your system is not low pass, then it will be a problem actually. So it means it introduces maybe high frequency comment as well. That leads to another problem with respect to the given nonlinearity. So your analysis will not be valid if you consider the system is having a poor filtering effect. So it's supposed to have a good low pass filtering effect. Right. This is basically Fourier series describe function, and if you look at the Fourier series, your y of t e will be written as a naught to t plus sum of a n cos omega t plus b n sin omega t, and a n and b n are defined as this. These are all we learned actually from maths classes, and there are nonlinear, there are symmetry, even symmetry and odd symmetry, and order of asymmetry with respect to the output nature of the nonlinearity. So if you say even symmetry, if you deal with even symmetry, y of t is supposed to be y of minus t, and there bn 0 and n is varying from 1 to n, and odd symmetry y of t is minus y of minus t, and an is equal to 0 here, and odd half asymmetry y of t is supposed to be minus y t plus or minus t by 2. So here a and b are equal to 0. So here we are dealing with mostly odd symmetry and odd of asymmetry for engineering applications. So mathematically we deal even symmetry as well, but engineering perspective, so far my experience also to just converge mostly towards odd symmetry and odd of asymmetry forms. This is your Fourier series of this. If you look at the sinusoidal waveform, right, this one single waveform, right? So this is a composite waveform. The moment you are introducing a third order harmonics, your response will be like this. So what happens here when you are introducing a fifth order third harmonic, it will be like this. So by adding these harmonics, if you look at this figure, that finally what it is, by adding a harmonic one by one, finally it becomes a square, right? This is what we see for a series of a square signal, how it is done. So the corresponding spectrum also given in the bottom of this figure, and I want to show you what are all that shapes, odd symmetry, odd half symmetry, and even symmetries are there. So this is basically some examples which is given here, even symmetry and odd symmetry and odd of symmetries examples. So we would like to see these are all signals. We would like to see non-linearities also with respect to the response. We would like to classify whether it's odd or odd of wave or even symmetry. But this presentation and this research is concerned, we are focusing more on odd symmetry and odd of symmetry, non-linearities. Just there are a few common nonlinearities in control systems, and if you look at this here, saturation is the biggest phenomenon, biggest problem associated with control system design. So this is one nonlinearity, and the second nonlinearity is here simple friction, and is the nonlinearity. Basically, this friction is basically Coulomb friction, and because Coulomb friction is a constant retardating friction. So and you have a dead zone. And another nonlinearity, we have a backlash. Mechanical gears, this is the diagram written here. Mechanical gears basically introduces such friction because of its movement actually from so that actually causes biggest problem actually when you deal with motor control systems, for example. So motor control system basically comes with gears. So your plant may be a linear, and this gears maybe introduces nonlinearity. So these kind of problems are easily handled by after in control system after predicting the limit cycles. One example is I'm going to show you maybe with respect to that. Let us move on to describing function of nonlinearity, how that describing function representations can be made for nonlinear systems. So let us see the plant here, and G2 is the plant, and G1 is the controller, and the n of x is the discrete function. So it basically represents a nonlinearity. And if you look at the equation, your x, this is your nonlinearity here, your x is the input and y is the output, and x is basically nothing but small x and the capital X sin omega t. We are giving sinusoidal input, and y is the output. It is basically y naught plus a1 sin cos omega t, b1 sin omega t. It goes like this, as from the equation we see in the previous equation. This can be expanded. And nonlinear characteristics, we are dealing with the odd symmetry or odd half symmetry. So the value of y naught is 0, and you are keeping input 0, and reference signal 0. Sorry, reference signal 0 here. The output n of x is feedback to its input through linear element T1 and T2. This is what we see from here. So, as we told that the closed tube dynamics should provide a good low-pass filtering effect. This is very important actually, because if any higher order, if nonlinearity is not approximated towards that, then it introduces harmonics, and if it sustains, then the characteristics and predictions will change. So we would like to see or ensure that this feedback systems provides better low-pass filtering effect. So just we are giving y, which is nothing but a1 cos omega t plus b1 sin omega t. So we are considering fundamental harmonics here, and we did work by including higher order harmonics as well in this equation. But this equation shows with respect to fundamental harmonics approximation towards fundamental harmonics, that is a1 cos omega t plus b1 sin omega t, and these are all corresponding equation. What is a1? What is b1? That's also written here. A1 with respect to cos and b1 with respect to sine. The magnitude will be written square root of b1 square plus a1 square, and phase will be written as tan inverse of a1 to b1. So we are saying that n of x, we have to derive the expression of n of x, basically nothing but a describing function, and it can be a function of x and omega as well. So now we are dealing with n of x, and we can also write function with respect to n of x and omega, just to make it to understand better. So I'm just making the function only with respect to x. And the transfer function is independent of input and frequency, and the limitation of this method, we would like to see here, it cannot ensure, the system cannot ensure low pass filtering effect. Not always. Therefore, the discrete function cannot be used for such a design. It is mainly used for stability analysis. So that's what normally we say here. And you can also see that describing functions, basically we said it predicts the existence on characteristics and of limit cycle, but these false identifications also cannot be ruled out. So what normally we do is we need to check after predicting the frequencies, predicting the magnitude and frequencies of limit cycle. We also check with the actual simulation for validation. This is equally important actually, because false identifications also possible. Let us just move on to how these can be derived. Some mathematics behind we are just presenting it now. And just I'm considering 3 different nonlinearities as we told in the previous slides. And one is on-off nonlinearity, which is basically switch. Switch is basically toggle between plus or minus m. This is what we see here. And we are giving input, right? X is the input, capital X and omega t is the input, and we are getting output as phi. So it's basically toggle between plus or minus m. So your output equation, your output y is basically nothing but plus m and minus m with respect to your angle 0 to pi plus m. This is what we see here, and minus plus pi to 2 pi, this minus m. So your Fourier series expansion is this, and this is basically a odd symmetry, and an and a naught is 0. So what will happen remains is only bn. So basically bn will be written 2 by 2 pi, 2 by t, 0 to t by sine omega t. So you are considering a full cycle, t equal to 2 pi, and simple substitution, just a max. So you can substitute y of t as m sine omega t when 0 to pi, and y of t as minus m, so pi to 2 pi. That's all. So here already we've seen with respect to here, y of t is pi 0 to pi and minus pi when the omega t is pi to 2 pi. Same thing we substituted here, and we have take the integrations, and after doing integration, finally you got like this 4m by pi sine omega t. So what is your discrete function? Output input. So output is y1 and input is small x1. So We can write 4m. So x is capital X sin omega t. So sin omega t will be cancelled, and the remaining what remains here is 4m by pi x. So this clearly indicates that how this n of x varies with respect to x, because m is constant, yes, and x is the varying quantity. So you need to vary x from 0 to infinity, and you can have a plot n of x. So it means what's happening when you are introducing a nonlinearity here is you have g of s. G of s basically s is basically we are substituting in frequency omega, and frequency is the running parameter. So 1 is omega, how g of j omega, how this function g is varying with respect to omega. That is what normally we do actually in your control theory. And another plot is basically n of x, where how x is, how this n of x is varying when we are varying x from 0 to infinity. So it means when you want to deal with such non-linearities, we need to have two plots. One is g of j omega plot, what you derive, what you see from the conventional theory, and second one is n of x. So we would like to understand with respect to these limit cycle behavior. Another example we would like to see here is a simple on-off with relay, on-off relay with dead zone. So we are introducing a dead zone here. Previously we had seen a relay, and we are introducing a dead zone where v plus or minus delta, and we are applying a sinusoidal input x sin omega t, and we got response because of the deadline dead. So till alpha no input, no outputs. And then it starts goes to regular to plus m until pi minus alpha. Then it becomes 0 till pi plus alpha. Then it goes to minus. So the same way we are writing the expression m is between alpha to pi minus alpha, and minus m goes from pi plus alpha to 2 pi minus alpha. So remaining outputs are 0. So only these two things we are just considering, limits we are considering, and we are writing this expression alpha to pi minus alpha m sin omega t, and pi plus alpha to 2 minus alpha minus m sin omega t. So just again you do the integration, and you get the output y of t as 4m by pi cos alpha times sin omega t. What is n of x now? y1 to phi x. Y1 is this 4m by pi cos alpha sin omega t, and what is small x? Small x is basically nothing but capital X sin omega t. So sin omega t, numerator sin omega t, denominator sin omega t will be cancelled. So you get the final n of x as 4m by pi x times cos alpha. Cos alpha can be replaced with this delta on this, and by doing simple max, we can be able to find square root of cos alpha. We replace with 1 minus del square by x square. So this also clearly indicating that your dead time, suppose if dead time varies, this function also definitely varies, and we are assuming dead time is constant, and here we are assuming x is varying between 0 to infinity. Another example of this case is backlash, and as you know, these mechanical gears basically introduces backlash, and here we are trying to understand how these backlash can be modeled. So we in terms of describing function. So we are giving x sin omega t input, and we got the output as shown here. And we write the outputs from the output signal. We are writing y of t, and then we are with limits. We are writing this equation, and finally we are finding the expression of your nonlinearity, which is like this. Because I'm skipping this because of my mathematical part. I'll share these slides. You won't go through this as well, because these are available in simple basic control system textbook. N of x is 1 by pi, and pi by 2 plus beta plus sine 2 beta by 2 plus j cos square b. So what do you see? What's the difference you see between the previous examples and this example? Previous example is relay and relay with its own. These are the two things we had seen. And now what we are seeing here is backlash. So previous things, it comes as 4m by pi x or 4m by pi square root of 1 minus del square by x square. This is what we see. There is no imaginary component there. So why it happens? The difference between this imaginary component is not present with respect to the previous example. With respect to the current example, we can able to see the j complex component. Actually, this is basically these nonlinearities are basically into two types. One is memory type, another one is non-memory type. So what you see in the previous examples are non-memory type. There is no memory required. But if you look at the backlash or hysteresis, all these things are basically memory elements. So these memory elements basically provides or introduces max as a complex variable form. So this is another challenging when you deal with the backlash kind of problems because memory elements like backlash systems, and this introduces complex systems. So just I would like to revisit what was seen in the previous slides, and we talk about odd symmetry nonlinearities, and examples are basically non-memory nonlinearities. We call it as example saturation and on-off relay. And odd half-phase symmetry is basically a backlash. It contains both real and imaginary. Even symmetry, which we are not going to talk about, and I don't have examples to describe that with respect to physical systems concerned. Okay, we'll just move on to stability and how the linear system stability is done using Nyquist plot. You know this, your feed-forward element is KGFS and feedback element is HFS. And using KGFS HFS is the open loop transfer function. And by using open loop transfer function, one can able to analyze the stability using Nyquist plot. And basically, it comes from conformal mapping. Hope you might have learned conformal mapping also. So this conformal mapping helps actually to establish this Nyquist plot. So here, what is happening here is we are just trying to understand any poles or bays in the right of a base plane. So we always bother about the open loop transfer function. Any open loop transfer function poles are placed in the right of base plane or not. So it means he's making the entire right of circle and analyzing the stability of the system. So if that can be divided into three sections. One is 0 to omega, varying from 0 to infinity, and this is minus infinity to 0, and this is a circle that indicates Re for j theta, where radius is infinity. So here corresponding Nyquist plot was drawn, and through the Nyquist plot, we are trying to check whether this system, closed loop system, is stable or not. The open loop system is available, and we are trying to check the closed loop stability of the system. So how it is done? Suppose if you have if you say, go back to next slide, and this is your characteristic polynomial 1 plus GH 8 m GH equal to 0, and basically you write 8 m GH equal to minus 1. It means you are minus 1 comma 0 is the critical point, right? So that's what we are writing here. Critical point is minus 1 plus or minus j here, and we are trying to understand. We are just see that whether any encirclement takes place actually with respect to minus 1 comma 0. Suppose if there is an encirclement, when you get that encirclement, that's what we would like to see. If you have open loop transfer function, and the open loop transfer function contains one, maybe for example, one pole in the right of a base plane with respect to previous. Suppose one pole at the right of base plane, that indicate that one encirclement will be takes place. So if there is no encirclement, means there is no pole on the right of the plane on the open loop systems. That's what the meaning is. So depending on the number of poles in the right of the plane with respect to function, the number of encirclements will be decided. So if you say there is no pole placed in the right of this plane open loop system, your closed system dynamics also should show that there is no encirclements with respect to minus 1 comma 0 critical point. This is what the theory explains in Nyquist plot. We are going to use this idea concept actually for taking the stability of nonlinear system. So here nfx is describing function, and g of j omega is the transfer function of the system. As I told you, you have g varies by means of omega 0 to infinity, and n of x varying from 0 to infinity. So you have two plots now. So now if you look at this this diagram, this equation. So your characteristic polynomial now is changing now. 1 plus n of x j omega equal to 0. Previously 1 plus g of j omega equal to 0 and g of j omega equal to minus 1. So your critical point is minus 1 there. But here what's happening here? Here 1 plus n of x g of j omega equal to 0. So it means your g of j omega is supposed to be minus 1 by n of x. This is what we see from here. So this is, so it means you have two plots. So one is this critical point is here, and one is a linear system as critical, and second one is 1 by n of x. So you have to draw plot g of omega as usual, how you are drawn actually from control theory. Just run the omega from 0 to infinity and draw the polar plot. And or you multiple polar plots, it becomes a Nyquist plot. That's one point. And second point is there's another plot here, minus 1 by n of x, where x is varying between 0 to infinity. So we have to see this, and then based on this, if you have two plots, definitely what will happen now, somewhere, someplace there is a crossing. So this crossing will be decided. The crossing will provide the information about the limit cycle behaviors. Just to showcase this example, I had given you a few plots here. One is stable limit cycle, and second one is unstable limit cycle. Just you look at this, you have two plots. One is this blue represents g of j omega, and running parameter is omega, and in this direction, it's varying from 0 to infinity here. And second one is 1 minus 1 by n of x, where this x is varying from 0 to infinity in this way. So you have to see the arrow mark as well. So now you look at this, here also two plots. Blue represents g of j omega and red represents minus 1 by n of x. How do you decide that the system, that crossing point is a stable crossing point or unstable crossing point? This is basically with respect to n circle. Your g of j omega, if it encircles minus 1 by n of x, the corresponding point with respect to the frequency and x in this direction, corresponding point is a stable point. So this here, if you look at this, g of j omega encircles minus 1 by n of x. And here, if you look at this, minus 1 by n of x encircles g of j omega. So this crossing point is a unstable crossing point. Similarly, you can also see, just in order to make you maybe a broader way, and just I made that minus 1 by n of x crosses twice. So if you look at this, blue represents g of j omega and red also this minus 1 by n of x, but the direction of this is given like this. So what happens here? This is outside. This is outside. This is outside of g of j omega. So this point K is unstable point, and this is inside of j omega encircles g of j omega. So this point B is a stable point. Similarly, you can see from here, but I changed the direction so to make you to understand better. So in some cases, so omega here this direction, but this is in the opposite direction. So what will happen now? So this is point A. The point A marked here is unstable point outside the encirclement, and this is point B is the inside the encirclement. So we made it as stable limit cycle point. So these actually, so there are multiple crossing as well. So depending on the nonlinearity which we deal with, and we may have multiple crossing points. So we would like to see whether the crossing points are stable crossing points or unstable crossing points. But if even multiple crossing points, if you have one stable crossing point, mostly it locked into the stable crossing point. This is what we observed from the simulations, various simulations in MATLAB. Okay, now we would like to see the a case study. And I would like to see the case study 1 with respect to simple on-off relay with the dead zone. And you may not believe this actually. So whatever we talk about is a very fundamental and which are available in practice. Just we used as a medium to design a controller later part. And here we are not going to give up details. And we published actually this work, actually extended of this work was published in I think ISA transaction elsewhere. So this bottom represents it's 1 minute. Yeah, you can able to see that paper novel control design for plant with relay nonlinearity to reduce amplitude of sustained oscillations. This is illustrated with motor systems, and what you see here is a simple backlash and simple on-off relay with the dead zone, and we consider a transfer function which is given in algorithm over textbook itself for simulations, because we try to understand with the basic text whether how these nonlinearities behaves with respect to different parameter variations and uncertainties. So this is what we initially experimented, and this greatly helped us to do certain design and development of controllers, in specific fractional controllers for such a system. Look at this here, g of j omega is this, and I have two case studies actually made for make you to understand better for this. One is k equal to 5 and the second is k equal to 50, and your discrete function as we already deal, right? 4 by m by x square root of 4 minus delta by x square. So here we are assuming delta equal to 0.1 and the magnitude we are keeping it as 1. So what's happening here, if you look at this g of j omega, forget about this because this is also g of j omega, because this is a Nyquist plot we are not. It means you have omega 0 to infinity and minus infinity 0. So these both the plots are there actually. So you can see from one plot, polar plot, varying 0 to omega, this plot. And this is your minus 1 by n of x. So it is lying on the real negative real axis here. And it goes from negative here and it comes to here and it penetrates and goes back. This is what's happening here. And if you look at this here, this also penetrates and it penetrates more and it comes back. This is with respect to different values of k. So if you have k5 and it just penetrates here and comes back, If you have k equal to 50, it penetrates beyond some value and it comes back. Anyway, so it means you have two crossing points. One is when it goes inside some frequency, it crosses g of j omega. After going inside, it is coming back. Then another cutting point. So twice it crosses, because this is in the minus 180 line, right? Negative real axis line. This is also seen from here. Twice it does. It goes inside, penetrates, and it comes back. So you have at two frequencies. You have your plot crosses g of j omega. Those values also written here, where the real value and the corresponding frequencies. So corresponding frequency, it shown us 11.2 and 11.1. Let us see these values later. So this is the simulation we performed with respect to the nonlinearity. So by keeping k equal to 5 and delta equal to 0.1, k equal to 50 and delta equal to 0.1. So this is the response. What in this, your set point is 1 here, and it provides a sustained oscillations here. But when you are increasing k equal to 50, your magnitude is very large. No longer it is oscillatory with respect to, so oscillated with respect to 1, but huge oscillations actually seen when you are changing the magnitude k from 5 to 10. But under the assumption that you are keeping the delta, the dead band is 0.1. Similar, that corresponding nonlinear input also seen here. Now, what is our assumption actually is there is an intersection point. That intersection point is minus 0.202, and when k equal to 5, and when k equal to 50, it is minus 2.03. You go back and see here, minus your real axis, which is shown here, minus 0.02, and in this case, where k equal to 50, minus 2.03. This is what I've written from this. And as I told you, it goes inside and comes back. So you have two frequencies, right? Two times it crosses g of j omega. The magnitude of first time is x1, that is 0.1104, and that is measured here. And x2 is 0.0 from the plot. From the x2, we measured as 0.02362. So it means, as I told you, it goes, penetrate, crosses, cuts, and it goes inside and it comes back. While going inside, there is a magnitude x. When it's coming outside, there is a magnitude. That's what we written as x1 and x2. And so the value of 1 by n of x at both the input values of x remain same. So there is no difference there. And with respect to stability, we would like to understand which x is stable. So the closed loop system is unstable for input x1 and stable for input x2. The reason because which is encircling what? G of j omega, this is coming from outside. So it means your first crossing point is unstable crossing point, and second crossing point is stable crossing point, because it is going inside, because this is G of j omega. Your 1 by n of x is away. So, but when you cross, after crossing, it is inside. When it comes, maybe it comes from inside. So it is encircles. Your j omega encircles minus 1 by n of x. That actually provides you this x2 as a stable. Similarly, we can observe from the second plot. And based on this, we are writing. So point, your limit cycle magnitude is this, 2362. And in case of k equal to 50, this is 2.6050. And from the simulation, also we ensure that whether the same thing happening or not, that is 0.2233, it is close to this value, it's 2. And when k equal to 50, the limit cycle magnitude 2.65, what is predicted from the Nyquist plot is 2.60, almost close to each other. So there is no much problem with respect to the frequency and the magnitude of we observed from this simulation and your graph. This is the observation with respect to the case study 1. And we also tried using this transfer function here, and k equal to 5 and k equal to 10, same thing we are considering. But instead of delta 0.1, we consider delta equal to 1. So what's happening here? There is no crossing at all. There is no crossing happen here. When you talk about k equal to 5, when we are varying delta equal to 1 from 0.1 to 1. But k equal to 50, delta equal to 1, I think it penetrates and goes inside and comes back. So it means what should happen here is there is no penetration here. And when k equal to 5, when delta equal to 1, and k equal to 50 and delta equal to 1, there is a penetration here. This is what we observed from the Nyquist plot. But what we see here is something different, peculiar, and this is what we simulated from the example given in control system book by rather than COBOL. And if you look at this here and if you look at this diagram, k equal to 5, delta equal to 0, it is 0. There is no oscillatory behavior. So that evidence from the previous response that there is no crossing. Here there is no crossing. Definitely there is no oscillation. This is what we supposed to see. That is seen here. But here, on the other hand, k equal to 50, it is penetrating, but it should be oscillatory, but it's not happening. Right? This is simulated with respect to unit step input. Magnitude is 1. Suppose if I'm for the same case study, k equal to 5 and delta equal to 1, k equal to 50 and delta equal to 1, I'm changing the magnitude. So we tested something like this, and how the response is. When the moment you are changing the magnitude from 1 to 1.5, it starts oscillating. So what it means actually is here there is no crossing, but there is oscillation here when you are changing the magnitude. That's what we said. Discrete function sometimes provides you the false predictions. So we need to check actually only through simulations. So hard simulations are really essential for validating this discrete functionality. This may be one of the limitations of this methodology, but we cannot rule them. The next case is oscillatory behavior is something like this. Now, let us see the magnitude, change in magnitude. The system starts oscillating like this, and is more oscillations is visible actually when you are seeing from k equal to 50 with delta equal to 1. You can also see I went with 5 magnitude of step, and it oscillatory behavior is something here, and this is my step input is something here, and here also oscillation is something like this. The moment I'm changing to 8, there is no oscillation again. There is no oscillation, but here that it introduces sustained oscillations. What you see here. So always for dealing who is dealing with the nonlinearities, so we need to check. Actually, we need to do both simultaneously in the sense describing function analysis and simulations. Basic simulations with nonlinearity should be done, and for verifications, these two are equally important. So this is observation with respect to what is learned actually from this. Intersection doesn't take place, and whatever I explained, it just I written in the form of notes. So here it's something's happening here. Here, so limit cycle is observed around the DC value of the system. The output is 0 for unit step input. So remaining things I have written here. Another example which I would like to show here is simple servo systems, because many of the robot applications or many systems normally we use precision systems. We use servo systems, but that we used to have a gears. These gears basically introduces backlash. So we would like to design a better control systems actually for such scenario. And this motivates us to introduce design, control system design, which is shown in the bottom of this slide. A novel framework to design and compare limit cycle minimizing controllers, demonstration with integer and fraction orders controllers. This was published in Nonlinear Dynamics, one of the good journal actually in Springer, I think. It was published in 2014. And this example, this is also from control system textbook from Govan, and using this, we design a controller, and here we are going to explain how this limit cycle is predicted. This is what we are going to show here. And so amplifier with motor, we are writing as a transfer function as 5 base plus 1. All these examples are there in the textbook. So this is backlash model is here, and you have a transfer function, you have a model, and this g of j omega is basically omega from 0 to infinity, and you have a red represents your main of x. Now you look at this. This is coming from outside. This is unstable point, and this is a stable point, right? So this is now you learned. So this stable point provides a real axis of -1.42 and the frequency of 1.59. This is what we see from the plot. This is the response which we obtained from the system. And the observation, what we see here is intersection of g of j omega and 1 by n of x. It happened to 2 plots, and we noted on 2 plots also here. And the second one, intersection point is a stable intersection point. That is, we observed from this, and corresponding magnitude 2.033, and limit cycle frequency, corresponding frequency is 1.59. So your final magnitude of oscillation is 0.959 because y is nothing but x minus h. So that gives you 0.959. So and see we are putting a note there. Unstable limit cycle never occurs physically. Describing function may or may not capture the existing limit cycle. This is what it is, the note which we written here. This is what we observed from simulations and real time in K with respect to the case study, what is shown here. So with the different K and delta, we plotted we applied graphical method and closed loop simulations for finding X in case of real relay with the dead zone. That is shown here. You're almost close to each other, and your backlash is also, if you look at it, backlash you also look at it, what 2.033 and 0.955. So it is very close to this one. So what we are trying to tell here is we are trying to explain that how these magnitudes and can be predicted, because these magnitudes are really these nonlinearities are really challenging, and this introduces sustained oscillations in the steady state. And if you would like to design some kind of controller, this has to be suppressed. This is the next topic of interest, and this presentation is concerned. We are focused more on how these nonlinearities can be dealt with. These are the references. We referred digital controls, and as I told you, basic control systems by Professor Nagaratan Gopal, and digital control and state variable systems by Gopal. And another interesting paper here is Professor Rangasamy Sridhar, and he's a pioneer actually, pioneer in nonlinearities. He tried to understand how these nonlinear behaviors can be because it can be suppressed actually, because he tried to deal with all biological signals, and he tried to understand how these nonlinearities affect system performance. And this he derived finally, because if you look at the literature, and there are around 27 nonlinearities in the systems, physical systems. What you see here is a simple relay systems, relay with backlash and maybe hysteresis and backlash and so on, dead zone and so on. But what actually in reality is there are 27 nonlinearities which are existed. So this is if you want to do the analysis, what happens is every time you have to derive the discrete function and we have to do. But Professor Sridhar came up with the idea that one simple thing is enough actually to make the analysis for all nonlinearities. That's why we call it that he written a paper as a general method. He generalized everything, all the nonlinearities, all 27 nonlinearities, a single nonlinearity, and he represented. It's a very interesting paper. You please go through it. It was published in IEEE Transaction Automatic Control. But Professor Sridhar passed away in the age of 29, I think, because of reason. But he is pioneer during that time, 60 to 63. He was pioneer. Many of the papers still useful for analyzing the nonlinearities and so on. So that's the one. And another interesting book is an open book only, so it is the copyright and everything gone. So you can able to download this book. So this is basically deals with multiple input and discrete functions and nonlinear system design. So it's a hardcore. They deal with nonlinearities. Professor actually, so one of the book we used to refer for nonlinear dynamical systems, and in specific nonlinearities, how to deal with nonlinearities, in specific discrete function analysis for nonlinear system design. So these three books maybe are useful, and there are many papers we published around, maybe something around 78 papers we published during the time of 2014 to 2020, and related to nonlinear dynamics, nonlinear dynamical systems. So just I would like to end up with my presentation, and what we learn, what we see from this presentation is how these nonlinearities and what is the behavior of nonlinearities, how these behavior of nonlinearities can be measured. So basically, behavior of nonlinearity can be measured with the help of this limit cycle behavior. So this is what we learned. That another interesting topic, maybe with my papers, you can maybe search through and gone through, and you can go through many papers related to how control system design can be performed for such nonlinearity. So those things are not presented here more time. So I want to give the essence of this nonlinearity, because automation required good control system design. This good control system design, in the sense we need to take all the nonlinearities, soft and hard nonlinearities into account when you do the design. So this actually maybe help you to explore some idea. At least you got some. If you are already working in this area, definitely you have got more idea about how these things can be done. And if you would like to work with this, you can maybe this could be a starting point actually to just learn the nonlinearities, and then you just see one or two control system designs how it can be done. Thank you for patient listening. If you have any questions, I'm ready to answer.
Thank you, sir. Thank you for your informative session, sir. Any questions from participants? You can unmute yourself.
Good evening, sir.
Yeah. Good evening. Yes.
For stability analysis, whether NIQ's plot is superior than Bode plot?
Yeah, actually, see, the reason I will tell you, because we Bode plot, because we learned this Bode plot and Nyquist plot only in the sense of linear systems. So in Bode plot, basically a Fourier plot. There are two plots. One is magnitude and another one is phase. Through magnitude and phase plot, normally we measure gain margin and phase margin, through which we can able to measure stability. But same thing, we are doing it for Nyquist plot as well. But here is a single plot. This is the only one difference. But that is one point. But I'm explaining only with respect to nonlinearity. When you want to deal with nonlinearity, this kind of it means your characteristic polynomial is 1 plus k times g of x and n of x. So equal to 0. So your g of x is supposed to be 1 minus 1 by n of x. This is what we see from the characteristic polynomial. This can be explored only with Nyquist plot, not with Bode plot. But if you look at it generalized, if you consider only linear systems, both are equally okay. Fine. There is no point in saying that which is superior, which provides you advantage. I don't say that way, but only with nonlinearity, it's your Nyquist plot is more powerful. Is only powerful. Yes.
Thank you, sir.
Sir, good evening, sir.
Yeah.
Yes, sir. Sir, what challenges do researchers face when modeling nonlinear system that exhibit the limit cycle, sir?
I don't know. Okay, just your voice is breaking. Can you repeat the question?
Yes. Sir, what challenges do researchers face when modeling a nonlinear system that exhibits limit cycle, sir?
Yeah. Because see, that's what I said. We can do many research. That's what I told. What we see here is it's basically even the nonlinearity also we are approximating into first order harmonics. But this is another problem. That's why I said simulation is equally important. So there's a much more challenge when you deal with nonlinearity when you are introducing other harmonics. If you are introducing in your equation, I will go back and just quickly tell you where the point comes from. You look at this here, your output is basically A1 cos omega t, B1 sin omega t. It goes like this actually. But in the limits in the basic theory, we restrict only to A1 cos omega t and B1 sin omega t. We are not considering the higher order harmonic here. That's why we call it as harmonic linearization. This is linear, but we tried with introducing a third order harmonics and a higher order harmonics. But only problem is that equation is huge. It's not that simple to compute compute and predict the limit cycle figure. It's much more complex, but we tried with the third harmonics, introducing the third harmonic in the sense with this equation, A3 cos omega t and B3 cos omega t, so sin omega t. So, and like that, A5 cos omega t, B5 assembly. We try to do with the third order harmonics and fifth order harmonics. The results are better, but only thing is it requires a lot of time in terms of derivations, because we need to derive first actually, then computation. This is a challenging part actually when you deal with when you want to get a better response, better results with respect to nonlinearity.
Yeah. Okay. Thank you, sir.
Any questions from participants? Okay, thank you all. Shall we conclude, sir?
Yeah, okay. If no questions, we'll conclude. We can share the slide. We can share the video also. Yeah. I will stop sharing now. Yeah. Yes, Dr. Rajay can go ahead.
Thank you, sir. Thank you for your enlightening lecture. In this August occasion, I invite Mr. K. Tangaraj, Assistant Professor, Department of EEE, to conclude the session.
Good evening, everyone. It is my great pleasure to extend a heartfelt vote of thanks as we conclude today's insightful session on limit cycle predictions for systems with nonlinearity. First and foremost, I would like to express my sincere gratitude to our esteemed expert Dr. N. Selvaraghavan sir for the remarkable presentation. The depth of knowledge shared on the complexities of nonlinearity and limit cycles has certainly provided us with a deep understanding of the topic. Your explanation and real-world applications have not only clarified intricate concepts but also sparked many ideas for further exploration in this fascinating field. Additionally, we would like to thank all the participants for your active involvement. As we conclude, we hope that the session has provided valuable insights that you can carry forward in your own research and studies. We look forward to more enlightening discussions in the future. Thank you.
Yeah, thank you. Thank you, Dr. Raja and team, for inviting me again. And once again, I thank you, Mrs.
Thank you, sir.
Thank you. Thank you, Dr. Raja. Bye.
Thank you, sir. Dear sir, madam, so there are important informations regarding the last day of 6-day online ATAL FDP program. So our second session will start by 3:30 p.m. and third session will start by 5 p.m. and we will be having feedback, both oral and written, that is scheduled from 6:30 to 7 p.m. and we'll be having an assessment in ATAL portal from 7 to 7:40 p.m. and followed by valedictory session. So kindly follow the schedule. So once we have completed the assessment as well as the feedback in ATAL portal, the certificate will be enabled. As per AICTE guidelines, so 80% attendance is mandatory, 70% of marks out of 100 in assessment is required, and completion of feedback questionnaires in ATAL portal. So these are the mandatory things we have to do in ATAL portal. After that only the participant certificate will be enabled. This is for your kind information. Please be connected, and our next session will start very soon.
So, having said that, in today's video, get ready to witness the most amazing smart factory automation, industrial manufacturing, and high-tech production with intelligent robots taking over most of the tasks. Hey, good morning everyone. This is Arthur and welcome back again to our channel. And if you are new here, click the subscribe button and click the notification bell so that you don't miss any of our great contents. So without further ado, let me take you to my number one. Number one, the industrial automation. Activity is one of the major characteristics that represents the era of the fourth industrial revolution. The cutting-edge technologies, which are closely connected like a spider web, is another characteristic of the era of hyperconnectivity. Industrial automation refers to the automated manufacturing system, including designing and producing stages through robots and computers. Continuing growth of the technology market, industrial automation has brought about changes to different industrial areas aside from the manufacturing sector, and distribution industry is one of the examples. The automated system has increased the working efficiency. Also, it has contributed to reducing errors that might occur during the working process. Industrial robot is the necessary element for the field of industrial automation. The recognition of environment has become possible along with the implementation of various sensors, and they have played a significant role for the automation of industries. Objective robot is one of the industrial robots that has garnered a lot of attention. As it can proceed works rapidly and increase productivity, it can realize coexistence with humans. Number two, a glimpse of smart factory of China. China's home appliance maker, Reliance, is fully automated at Chengdu, Guangdong. It has 4 smart production lines, and each of them are equipped with 17 mechanical arms. The robotic arms are in charge of manufacturing, including material input, processing, and assembly. On average, a product rolls off the assembly line every 6.7 seconds. The factory has an annual production capacity of 11 million home appliances. Glass factory. In Kentucky is Kearney's oldest glass factory. It was built in the 1950s to create lenses for glasses, and then in the 1980s, it transitioned into making LCD glass panels. But about 6 months before the first iPhone was released in 2007, Steve Jobs made a call to the CEO of Corning and asked the company to create glass that could withstand scratches and breakage for a new Apple product.
Good afternoon, everyone. So today,
Good afternoon,
Hello, hello.
good afternoon, ma'am.
Hello, sir. Good afternoon, good afternoon. Good afternoon, Jam.
Shall we start, ma'am?
Yes, sure. So I'll share the screen.
good afternoon to all. Session number 12, topic quality control and assurance, techniques for maintaining standards. Our expert, Dr. Kalachari ma'am, is here. Time to introduce our expert. Good afternoon to all. It is my great pleasure to introduce Dr. J. Kalachari ma'am, a distinguished academic and researcher in the field of power electronics and drives. She completed her PhD at the prestigious Indian Institute of Technology, Madras, specializing in power electronics and drives. Since 2016, She has been associated with IIT Ropar, where she has made significant contributions to both academia and research. Her expertise has led to publication of numerous papers in leading IEEE journals and conferences, reflecting her profound impact of the field. Additionally, she has successfully secured several funded research projects, collaborating with prominent organizations such as the DST, Defense Ordnance Sector, and Punjab government. Her research interest includes conduction mode EMI issues in motor drive, fault diagnosis, and fault tolerance control in power converters and motor drives. Her work in this area has paved the way for advancement in reliability and efficiency of power electronic system. So we are truly honored to have her with us today as a speaker for the ATAL Faculty Development Program, and we look forward to gaining valuable insights from her expertise. With great pleasure, I now hand over the session to Dr. Kalechavi ma'am. Welcome ma'am. Please take over.
Thank you. Thank you, sir. Thank you so much for your introduction. So I'm Kalai Selvi, working as an assistant professor in Department of Electrical Engineering, IIT Ropar. So my today's topic is quality control and assurance techniques for maintaining standards. So in specific, I'm going to take motor drives, induction motor and BLDC motor drives, which are used in various applications such as industrial and electric vehicle and so on. So in such application, how this conduction mode EMI issues are going to create a problem, and in turn what are all the standards we will have to adopt to not disturb any other applications in the line, and hence we can maintain, we can operate other systems without any disturbance. Okay, so my flow of talk goes like this. So first, introduction to the topic, benefits and applications of motor drives, and adverse effects of the variable frequency drives or inverter fed motor drive. And I would define what is conduction mode EMI, and then some of the methods which are used for induction motors and as well as BLDC motor drive, and the filters, basically the filters. So this research is done by my student here. So, and then I'll briefly summarize the talk. So if we know that we all know that induction motor is very widely used almost in all of the applications. You take any industry, you will not be able to find an industry without induction motor. They are called workhorse of the industry because they are low cost, simple, and robustness, highly robust, and requires very low maintenance, and it is very widely used in pumps, compressor and conveyor systems, electric traction and machine tools, etc. Whereas BLDC motor is little bit reliable and efficient in comparison to the induction motor because of the use of permanent magnets, and it's precise in control and high durability and efficiency is high. And compared to the induction motor drive, this has little bit wider speed torque control region, and it's more used in robotics, electric vehicle, pumps, UAVs and so on. And so now if we see in these motor drives, induction motors are driven with the direct sinusoidal supply, as well as VFDs, variable frequency drive, because if you want to control the speed and torque effectively, then you have to go for variable frequency drives. Whereas BLDC motor drive, since the requirement of the position sensors is mandatory, so from the position you have to control the excitation of the winding, so that requires again converter. So BLDC cannot be operated without converters. So it's part of the motor. As part of the motor drive, we'll have both converter and motor in BLDC motor. Okay, so first we will look at what is variable frequency drive. So So if you see here, so any motor, if we see the purpose of motor in any of the applications, you take induction motor or BLDC motor. What we do is we connect the motor with load, with the mechanical load. So where we will connect, we will connect in the shaft. We'll attach the load in the shaft. Our aim is to generally control the speed or torque of the load. That has to be, in turn, should be controlled by the motor, right? So now motor means we know that it converts electrical energy to the mechanical energy. So now we need to look at how we will control the speed and torque through the electrical port. So what are all the electrical variables which is going to affect the speed and torque of the motor, that we first need to know. So we need to know the relationship between the electrical port and the mechanical port output parameter, and hence you can control the speed of the machine, and therefore you can control the load speed by varying the speed of the machine. And torque, anyway, if a machine is coupled with the load, if you have a load torque is equal to machine torque only, equilibrium point would be achieved, right? So therefore, by changing the speed and by changing the voltage and frequency of the input, we can change the speed and torque of the machine for induction motor. And similar to that, for BLDC motor also, we can change the voltage, and hence we can change the speed and torque of the BLDC motor. So the purpose of the power electronic converter here is, so we have various configurations are available. It can be a controlled rectifier or uncontrolled rectifier, but inverter generally does variable voltage and variable frequency conversion. So this is the overall structure of your VFDs, right? So now we know that in VFDs we have a power converters which are used, which is they are switched at high frequency, so that you can reduce the filter effort in some places. See, if you do through PWMs, your noises are shifted to high frequency, and therefore it is easy to filter out. And in some applications, the machine inductance itself will act as the filter, and therefore you don't need filters itself. So many benefit, and also it's possible to vary the amplitude using the PWM method in comparison to the 180-degree conduction mode. So therefore it's preferred to use high frequency switching or PWM methods, but because of that we'll have some unwanted effects in the system, which are then categorized into common mode, differential mode noise, EMI, shaft voltage, and bearing currents. This, what would be the issue? They in overall, see, any product if we buy, we need to meet EMI standards. So when we buy the product, that each particular products are certified by Indian government, as well as there are international standards, so that it won't create a trouble for its own system, and as well it doesn't have an impact with the other systems. So let's understand first what is conduction mode and differential mode EMI. So now if you see, what is EMI? Electromagnetic interference, as the name indicates, both electric and magnetic fields, how it's creating the degrades the performance of the device. So you want some equipment to do only some specific purpose, but it's not simply doing that purpose. Along with it, it also brings some other unwanted effects. So now if you see, there is an inductive coupling, there is a source, there is an inductive coupling, and through the capacitance there is a load. So now through the conduction, if any noise is getting interacted, so there might be a parasitic capacitances, right? Through the inductive coupling or capacitive coupling, if there is a current flow which is happening into the unwanted places through conductive wires, then that is called conduction mode EMI. Whereas, like our proximity effect, so if any, see, you are passing a current through any wire. Let's say any wire is carrying the current. There will be a magnetic field around each of the wire. We know that, right? So this magnetic field would interact with any other nearby equipment because there is a magnetic field around that component, and causing other interference in the other system is called radiative electromagnetic interference. It will act like an antenna basically, and victim will act like a receiver. Okay, so conduction mode AMI generally is defined within the frequency range of 150 kilohertz to 30 megahertz. Radiated AMI is about 30 megahertz to, I think, around 15 or 30 gigahertz. So in power processing system, mainly in power electronics, main EMI sources switching element, that is your switches, which we are using it for high efficient purposes, and inherent parasitic capacitances in the circuit, right? Okay, so I'll explain how inherently parasitic capacitance would be present in the system. So, and then we'll move on to what is shaft voltage and bearing currents. Okay, so now if we see, this is the equivalent circuit of, lumped parameter equivalent circuit of an induction motor drive. So we have a common mode voltage source. I think, yeah, we have a common mode voltage source. Here, this neutral point of the stator is connected with the neutral point of the rotor through some of the parasitic capacitances. We can see here, if you cut the machine and look at the equivalent circuit, right? If you cut the machine and look at the equivalent circuit, between each of the conductive elements, you will see basically how the capacitance is formulated between two plates. There is a field medium, right? So now here, all of the stator frame and everything would be operating at different potential. When you can recognize there is a capacitances, so there is a field medium, air is there, and each of these are operating at a different potential. Rotor would operate at a different potential, frame would be at 0, and each winding will have some potential differences as well. And hence you will have a various parasitic capacitances would be enabled inside the machine. So whenever there is a change in voltage, or if there is a change in frequency, this would impact the system. So because of change in voltage, or if you switch at high frequency, obviously the capacitance is going to offer a low impedance path. So you will formulate a capacitance divider. So we are taking only the major parasitic capacitances in a lumped manner. And so this is the bearing. Bearing can be modeled as the capacitor with a nonlinear switch in parallel. So whenever this CRF is nothing but your air gap. CWR is winding to rotor, and this is winding to frame. This air gap voltage, whenever exceeds the lubrication of the bearing, then there will be arc kind of thing would be formulated, and this would affect the metal of the bearing. So it permanently marks some pattern in the bearing, which in turn affects the reliability of the machine. So shaft voltage and bearing current, both of them are problem along with the EMI. So since I have defined already common mode and differential mode noise, let's look at what is common mode and differential mode noise. Say now we have two wires in a two-wire system, and we also have a third wire, which is the ground, right? So if there is a ground, between each wire, the current flow can happen in the load, or even if there is a parasitic capacitances between the two wires. So the current flow responsible between the two wires is V1 minus V2. Let's say this wire voltage is V1 and this wire voltage is V2. The current between the two wires is because of V1 minus V2. That is called differential mode voltage. And let's say you have a parasitic capacitance between each wire to the ground. There will be current between each wire to the ground, and the source we can say commonly that V1 plus V2 by 2, because if you assume the impedances are equal, right? So then the current flowing from each wire to the ground is called common mode current or the ground current, and the source is the addition of these two voltages. If the impedances are same, then you can say average of these two voltages. It is in the two wire system. Let's say you have a 3-wire system, extend the same concept. You have wires to the from ground capacitances, and therefore average of all these voltages is called common mode voltage, because all of them are allowing the current to the ground. And this is also called zero sequence voltage, which we have studied, how we will define the unbalanced system, zero sequence, positive sequence and negative sequence. So this is also called zero sequence in the star connected and delta connected system. Similarly, you can see differential mode as between two wires, whatever is allowing the current. So obviously it will be a line to line voltage, right? So now you can see here, this dotted line is the differential mode noise, and the solid line is the common mode noise. So it comes to the ground and then circulate it in the system, whereas the differential mode noise just circulate between the wires. So as I said before, it is the source of EMI. It is also going to create an insulation failure. It's also going to create shaft voltage and bearing current. So if we address all of them, we would be able to improve the safety of its own system, and as well we can be able to improve the nearby system safety, and we also can improve the overall reliability of the motor drive system. So the goal is to improve the life of the system or improve the safety of the nearby equipment by addressing all of these adverse effects. So the effects of it is, as I said already, it will create a control disturbance in its own system as well as a nearby system, right? It will provide fault tripping in the protection system, insulation failure, electronic malfunctioning. This is, much more possible. Navigation and communications, and even safety in case of EV applications and so on. So there are a few examples I had given. F-16 fighter jet system crashed because of this is a source from NASA, right? And Mercedes-Benz anti-lock braking failure happened because of EMI issues, right? So there are specific standards already defined by various organizations. So EN 61000 is used for industrial application, IEC power station and substation, and DO 160 is for aerospace application, EN 550022 for information technology applications. So these are all the standard applications which are applied for each of the applications. Household also we have, right? So what are all the solutions we can adopt? So we know that there is a EMI source and someone is receiving, right? And then propagation path is there. So first we can try to reduce the source by whatever the options we have. Obviously we need to switch. So is there any modified PWM method or control method you can adopt so that you can reduce the impact of EMI in its own system, and modify the propagation path? What does it mean by propagation path? Try to provide an impedance for only high frequency noises without affecting the original power flow. And passive active filter, and this can be summarized here. So you can see this is the source in the motor drive, so we can try to control through this itself, and then you can use something in the propagation, or each localized solution you can give it for the shaft voltage and bearing current problem. Okay, so now this is the typical motor drive system. So what we do generally, we will have something called line impedance stabilization network to measure the EMI first. What is the purpose of this line impedance stabilization network? Is it act as kind of a filter network, what it does is it doesn't allow any external noise coming from the source. It will help you to measure the system noise only, your own system noise. It won't allow this system noise to the other side, or it won't allow the source side to this side. So that's the purpose of line impedance noise stabilization network, so that you can measure the noises locally of their own system. Otherwise, in general, these noises would flow from one source to the other source, because the ground is in general common for all of the household appliances. Why do we ground? We ground because we want to have much higher safety, right? So, so this is the inverter and this is the motor system, and I have put for simplicity DC side only. AC side part of it is not there. So it is mandatory anyway, so you need to employ some method to meet the standard. And suppose if you are using SIC inverter, I hope we all are aware that the power electronics field is moving from silicon based inverters to, or silicon based converters to SIC converters, wide band gap devices, which has a higher efficiency, higher force time, fast acting switches. So this can rise and fall in a few nanoseconds, and hence you can switch at very high frequency, and hence therefore power density can be improved. You can make it very compact. And therefore SIC inverters are now emerging in many of the fields of power electronics. And so to protect, to meet the standards, we need to meet the use the filters, some filters or active methods or control methods or so on, right? So there are two places in general EMI filters can be adopted. In some applications, both of them has to be adopted. One is input EMI filter, another one is output EMI filter. If in some of the mostly electric vehicle applications, both the places there will be a filter, right? So because some noises would be bypassed through these capacitors, they are decoupled. The noises are decoupled. One, if you install a filter on the front end side, it won't completely elevate on the output side, right? So overall, they would improve the efficiency and speed torque of high speed, mainly on the high speed motor drive. Installation issues will be improved, and these are all mandatory to put in the input side. So now once we define the noise, once we define the system, how do we measure the CM and DM noise? So we have to opt this LISAN, then you can, as part of the LISAN itself, there are probe, and the EMI setup will have separate probes. If you don't have, you can measure it this way. If it is a two-wire system, you add all two of these current and divided by 2 for CM. DM means IX minus IY. If IX and IY are this, right? Then if you go for AC side, which is the three-phase AC side, it's a little bit difficult. This is one of the method used. There are other methods also. Addition of all of these currents are common mode current. As I defined before, the voltages current also have the same definition. IA plus IB plus IC divided by 3. And then to find DA noise, basically what we are assuming is each line current IA has both common mode and differential mode. If you subtract the common mode noise, what is remaining is the differential mode noise. So that's the idea. So IDMA equal to IA minus ICM. IDMB is equal to IB minus ICM. IDMC is equal to IC minus ICM. So this is the expression, you would get it. Right? So this is how we measure. So what we do for differential mode measurement, we will put one turn over here to have a different sign than the other. And here you just clamp all three wire together and measure. You can measure the common mode noise. Differential mode noise, one wire you will have to do one turn. Rest of the wire you can insert as it is to get this expression. If you are using the clamping probe, right? So now So there are, before we understand, what is CM current, how do we measure? See, as I said, now you have to clamp all three wires together to measure the noise, right? So now the expression of CM current is VCM by ZCM. So first we need to know how the machine or the load is acting like for a common mode source. So what we do is we short all three wires in both the already if it is a star connected side, that side of the machine would always be shorted. This side you will have a shorted wire, so you connect it to the impedance analyzer and look at the common mode impedance pattern, how the common mode impedance pattern comes, and similarly for differential mode. So this is for induction motor drive, the common mode impedance per phase and their particular phase angle as well, right? So now if you see, so we know what is the impedance profile at what frequency. As you can see, as the capacitance behavior is going down, I mean increasing, as the frequency is increasing, you can see the impedance is dropping with increasing frequency, the machine. And what we want to use is we want to use the machine at 50 hertz, but if the frequency, high frequency excitation happens, obviously you're going to have a various frequency components if you switch at high frequency. So those frequency components met with these impedance is going to cause particular current in each of these frequencies. So the common mode equivalent circuit can be defined something like this. If there is a common mode voltage source, which is VAO plus VBO plus VCO, and there are impedances which are connected. And this is the motor parasitic capacitance divider, whatever I have mentioned before, it is the same network, right? So now we can define what is shaft voltage and what is common mode current. This is the CM impedance of the CM inductor designed at 20 kilohertz and 200 kilohertz. Because I was talking about the SIC inverter, to understand the difference between 20 kilohertz, what will happen in 200 kilohertz, what would happen. The difference is ideal case and the 200 kilohertz. If you see, the impedance resonance is happening very faster because of various parasitic capacitances in the inductance itself. If you make an inductor, if you are making an inductor for low frequencies and high frequencies, that have a different impact in the system. So in 20 kilohertz, if you make, the resonant point is somewhat far away compared to the 200 kilohertz. This is one of the other problem which we need to face it. So basically, you are going to have higher and higher noises if you switch at high frequency, as you can see from here. And the inductances, whatever you are going to make, it also is not going to be really effective if you are making with very high inductance. This is what it means. If you see here, 50 millihenry is resonating almost at 100 kilohertz. It means it's not going to eliminate any of these noises. Maximum what can happen is, if this capacitance is much lower than the other capacitance, probably it will have reduced the noises, but it won't attenuate basically. If you see, whereas 2 millihenry, you can see it here. So the solid lines in here, still compared to 20 kilohertz, 200 kilohertz, there is a small difference, but still, 200 kilohertz has a resonant frequency early. What does it mean, resonant frequency? It will act as the inductor only in this duration, and it is becoming as a capacitor after that. That's what resonant frequency means, right? So in general, you expect the inductance means with respect to frequency, the impedance has to keep on increasing, which doesn't happen in any of the practical system. At some point, it will resonate. Okay. So these are all the two problems which we had seen now. If you are going to increase the frequency with the SiC MOSFET or the wide band gap devices, you are going to have a higher and higher noises, and the solutions which you are going to employ is also going to have common problems. So now if you see, this is the plot of noises between the common mode voltage at 200 kilohertz and at 20 kilohertz. And similarly, differential mode voltage at 200 kilohertz and at 20 kilohertz. These, you can see there is a shift. Basically, it is a different frequencies, right? So the noise frequency spectrum is getting shifted, whereas here, if you can very clearly see, the currents are generally problem, not the voltages. So if you see the common mode and differential mode current here, you can see here 200 kilohertz noise is higher than the 20 kilohertz. So same here, DM current as well as CM current. So it is because, as I said before, for higher frequency, the capacitances would act like a more of a short circuit, right? Higher the frequency, impedance would be lower. So now the motivation of the workers, we seen that increased conduction mode EMI noise in SIC inverter fed drive, and the CM inductor, which are designed at 200 kilohertz, increase the volume due to decrease in permeability. See, the entire idea of going to the SIC drive is, one is obviously it has a higher conduction to, thermal conduction, and it can rise and faster, and therefore you can switch at high frequency. When you switch at high frequency, the benefit is to reduce the filtering effect. So we could have seen that if you are switching at high frequencies, the magnetic core volume would go down, and the impedance requirement, say, let's say if I need 10 ohm for my application, and if you use the frequency of 5 kilohertz and 10 kilohertz, for say meeting the same impedance, you need lower inductance at the higher frequency, right? And deteriorated performance of a CM inductor at high frequencies. These are all the three motivation why we are going for some specific solutions. So design, there are existing EMI filter already. Design the single stage EMI filter with less volume of CM inductance. How is it possible? Because we had seen that here, that if your inductance value is small, the resonance is very closer. So if possible, you design the EMI filter with less value of CM inductance, modify the design procedure such a way you can minimize the CM inductance, and design a EMI filter with reduced size and number of components to meet the increased noise attenuation demand, so that your cost and volume, main idea is here to minimize the volume, weight and cost, achieving the improved performance while minimizing the volume, weight and cost. Okay, so now conventionally there is an EMI filter. So this is the EMI filter. There is LC. So basically what is common mode choke is, you wind three winding on a same core, right, in a same direction. So the entry of the current has to be in the same direction. Therefore it would offer the highest impedance for the common mode noise, but for the actual noise, which is not actual power flow which is happening, which is differential mode, it won't offer any impedances. So this is then called common mode choke. What is common mode choke is, it would allow and it would provide an impedance, or the highest flux would be formulated only for current which are flowing in the same direction. That's what this dot indicates. This will offer a higher impedance only for current which are flowing in the same direction, and this LDM is the normal inductor, generally whatever we use. And these two are the capacitances and resistances for differential mode, because their paths are different, and this is for common mode impedances. So basically LC, CC, RC is generally for common mode filter, LD, CD, RD is for differential mode filter. This is like any other filter, but simplified procedure. So now if you see if you take just a differential mode impedance, what is done? LDCD would offer, so any series inductance would give an inductance will give a attenuation for the series, and generally inductors will give higher attenuation for the high frequency component, because we don't want to have any attenuation for the low frequency component, because the machine is operating at 50 hertz. We want our 50 hertz component to flow in the system, right? So now the capacitance, what does it do? It will bypass the high frequency component, and this is for providing a damping. Same for here as well. So now this basically idea is to bypass and inject a very small small amount of noise into the DC midpoint, the or DC bus negative, right? So therefore the noises which has to flow in this path is diverted to this path. Once you attenuate the noise, it will only flow in this path, it will circulate only in the system, right? So that's the idea. So now what we did, we didn't first insert this LCM. What we found is, if you just what they have done in the literature is, they independently designed LD, CD, RD. There is a filter attenuation, and LC, CC, RC separate filter attenuation. They have kept a goal, and then they have attenuated and they have provided the solution. So what we found, this LDCD-RD alone, if you connect it to the midpoint without LCCCRC, that is providing the attenuation of same for both common mode and differential mode noise. You can also see it. See, if you're not connecting this point to the ground, it will just bypass the current through these lines. But you connect it to this point, even whether you have a LC or not, you will have a attenuation happens here. The only problem is, for a common mode, each phase this will give LD by 3, LD by 3, LD by 3, but this will act like a 3CD. See, common mode in the sense how all three of them can be combined and seen as the one impedance, right? So that is LD by 3 and 3CD. And for DM, it is simply LD and CD. So what we did, we designed for attenuation first equal CM and DM attenuation, and then we added a small amount of LCM just to attenuate or meet the series how much amount of the noise we want to be attenuated. So therefore, compared to here, the inductance value is minimized. See here, you can see here 2 millihenry is through conventional single stage filter, whereas that has been minimized to less than half in our design. And therefore, you can also, there are two benefits, as I said before. Now my inductance value is less, therefore the resonant frequency point is also being shifted. And obviously, when you are minimizing the inductance value, your core size will go down. So this is first stage filter what we designed. And then, because if you can minimize the inductances and capacitances, and if you can, your bandwidth of the attenuation can increase. This is what we understood. And hence, what we did, we have designed the multi-stage EMI filter so that you can attenuate the noises, right? Can I stop here and take questions if you have doubts, so that I can continue? Any doubts until now? Any doubts?
Is there any questions from participant side?
Yeah, any questions are there? We can have a discussions before we keep going without anything. Need not be on the CM noise or EDM noise. Anything until now, whatever I have presented about the motor drive system or anything.
Question from audience side.
Good evening.
Yes, good evening.
Ma'am, for example, if we want to measure the CMD, and if we have an inverter, but there is no DC bus, that is DC link, is not there, then how can we measure the CMV, ma'am?
See, CMV, voltage or current? What is that?
CMV, oh, it is a current, ma'am. Voltage, CMV voltage.
Okay. So, see, for in general, so I'll go to the circuit. See, what you are saying is you don't have a DC link midpoint. This one is
Yes,
not
ma'am.
there.
Yes, ma'am. Yes, ma'am.
So how then inverter is taking the input basically through a direct DC supply?
Direct DC supply. Yes, ma'am.
Right, fine, no issue. So now in this place, because if you're having a direct DC supply, you don't need a DC link, right?
Yes, ma'am.
Okay. So now in general, DC link voltage is generally you can measure between neutral to frame, because this, if you look at my definition, VCM is VAO plus VBO plus VCO by 3. Addition happens in the neutral point of the machine, right?
Yes, ma'am.
So what generally done is measure the neutral to the frame voltage, that is common mode voltage of the machine. Right? If you want to measure the common mode voltage of the inverter, add all of 3 of the voltage and divide it by 3. VAO, VBO, pole voltages addition divided by 3. If it is a delta connected machine, people will make an artificial star connected very high value of resistance so that there won't be any much current flow here. They'll make an artificial network and will measure. That is for common mode voltage. For current, it's sufficient if you have these 2 wires, right? You just join these two, you allow the current through, see these 2 wires, you allow it through one common probe. If it is a clamping probe, you just pass the 2 wires in the same direction. That's it. That is common mode current. And here, the same 3 currents, you pass it in the through the same wire. If it is a
That
clamping.
means a clamping meter. Through the clamping meter, if we measure the current through all the 3 wires at the same time, then it will become a
In the
common
same
mode current.
direction. In the same direction. That is then common mode current.
Okay, ma'am. Okay. Thank you, ma'am.
So any other queries?
You can proceed now.
Okay, right. Okay, so what we did, it's simple. So generally the design of the any other normal passive filter, you choose the cutoff frequency. General cutoff frequency to avoid the disturbances at the low frequency side or interaction on the switching frequency side. The resonant frequency has to be in between the fundamental frequency and switching frequency. So we have switched at 200 kilohertz. So this has to be somewhere in middle, and 50 hertz is this thing. So I think we have designed around 20 kilohertz so that your volume of the filter would be very less. So for the differential mode noise, what is the major goal is how much is the allowable ripple on the machine side. So accordingly, you will design the LD value. And then it depends on the attenuation, you design your CD value. After selecting, then you can calculate the F resonance. So this is for DM and CM. And the one of the goal has to be XL has to be much greater than XC, because attenuation should happen higher. If inductance is higher, attenuation will happen. If capacitance is higher, or what will happen, the noise would just circulate inside the system. You're just bypassing it, right? You are not removing the noise from the system. So what we did, first we designed the CM and DM attenuation of 24 dB, and then additional 20 dB, whatever is required, we used the CM inductor. So generally attenuation is decided by 40 log F switching frequency by F resonance, right? Then this is the modified multi-stage. What we did, as I said, if you reduce the inductance's values, the bandwidth of the attenuation is increasing for the passive case. So what is done then, there are two filters we have extended. One is just add another LCM only on the this side. This is the single stage filter. We added one more LCM, and the machine capacitance together was acting the second stage filter cutoff frequency. So what we did, this is the equivalent circuit for CM. So if you see here, this LCM and these capacitance together act like a second stage attenuation. The first stage attenuation is decided by, as it is, the LCM and CC, 3CD and LD and CD here for the differential mode. So then what we did, we have again fixed the first stage attenuation at 34 dB. Second stage we have got for 11 dB alone, we used the second stage. So we need, why we are going for that highest attenuation with the first stages, you are bypassing something, right? So the bypassing noise otherwise would be coming more in the secondary system, secondary side, or which will again flow through the machine, right? So then similarly, in the second stage, what we did, instead leaving the cutoff frequency to the machine, parasitics, which we don't have a control. What we did, we added another filter capacitances and resistances, and then we have connected back to the ground. This was second stage noise is injected to the ground. So because very small amount of noise is coming in the second stage, and then further it's getting attenuated, so we didn't inject much of the noise in the ground. It would be much lesser than the standards. So the again first stage 34 dB, second stage 11 dB. If you look at the volume comparison, that was the objective of the work. If you see this is the volume, right? 4.972 single stage compared to single stage multi-stage 1 has only this much, whereas modified multi-stage 2 has this much comparisons of weight and cost. So modified multi-stage EMI filter 2 is better. So this was able to reduce the volume by 27%, and we were able to reduce the weight by 54% and cost by 59%. So now this is the setup which we have used. So this is called LISIN, and we also have a network analyzer which I have not put here. That is the MI spectrum analyzer. And this is the SIC inverter. We were using DSP controller, and this is the filter which has been used. These are all the CMV measurement probe, and this is CM current measurement, and this is the induction motor, and this is the current probe, and this is the oscilloscope, right? So this is the rating of the inverter and the motor. We have motor is though 1.1 kilowatt. We have verified up to 600 watt, because the noise level for just 300 volt itself is very high. If we are going for full 560 volt, then it would be much more higher. It is not possible to attenuate as well, right? So this we measured all of the filter attenuation. Physically, if you make there is an ideal attenuation, but when we measure the attenuation, we would see, because of the physical limits of the actual elements, you will have the attenuation. Even filters will have its own resonant frequency. Up to what frequency this will act like inductance and capacitance. Even if it is acting as a capacitance, is it better than before? That is what we need to see. So this is the single stage EMI filter. You can see modified multi-stage EMI filter has a little bit, there are no two resonances here. This is much better, but this has a little bit, modified EMI filter 2 has a much better attenuation. Even though all of them are designed at 44 dB attenuation, you can see the bands of impedances, how these filter networks are offering. So this is being measured by the impedance analyzer, and similarly here as well. So this is with the shielded cable. What we did is we inserted a cable because to understand the effect of cables in the filters, right? So with the filters, what is happening? How much attenuation is increasing? MS1. So when for a shielded, unshielded cable, multi-stage 1 is much better. because of natural the capacitance of the cable is adding the attenuation higher, and therefore this is providing the better result for cable, right? And this is the attenuation, how much we actually received, and these are all the results. So you can see here very clearly, this is the line voltage and line current of, if you are not implementing any filter, this much amount of noises are normally imposed on the SIC inverter. If you are switching at 200 kilohertz, you will really see a very bad noise on the system. The SIC inverter cannot be used in any applications without filter, mainly for induction motor. This is clear. If you are going for less frequency, you can still use it for an applications without filter. So then we measured the THTs and at these voltages. If you see with the filter, this is not just eliminating the common mode and differential mode noise, it's also THT is gone to the voltage itself 4.41 and for current 3.59. And this is the line currents of at various operating conditions. I think under loaded conditions at rated load current of 2.55 ampere. So this is the measured noise. So this is ICM and this is IDM. With all of these single stage filter, you can see in time domain all these noises are gone. And in the multi-stage and single stage, so this is the shaft voltage. You can see all of these filters has eliminated almost all of them, right? So we were looking at the how much is the peak value, how much in the time domain the results. It's very minimal. And this is the resonant frequencies of each individual component analysis. How, if you see higher the value of the capacitance, the resonant frequency would be lower. Similarly, higher the value of inductance, resonant frequency would be lower. So where we will see the resonant frequency, you look at the phase plot where what is crossing. You can see here LCM1 has 7.1 megahertz, whereas LCM1 single stage has 2.3 megahertz. So the self resonance is lower in the lower value of this thing. So this is important to understand why the multi-stage filter has the wider bandwidth of attenuation. So now you can see the noises of, so this is bare CM noise. The single stage filter is exceeding the noise in some particular region, you can see here. And even multi-stage filter 1 also in very small this thing here. And whereas multi-stage 2 is able to go with lower current in all of these frequency ranges. Same here for DM. And this is at different switching frequencies and modulation index, modulation index of 0.5, and this is modulation index of 1. And here the same DM noise at different modulation index. You can see these here for DM noises, all of them are almost acting good, except the modified single stage filter noise is still bad. Okay, so then we also looked at with the shielded cable how it is attenuating, and then with the cable how the currents are getting changed, inductor current, how much. So this again we need, because we have inserted some filters, we need to analyze the loss analysis, how much is happening where. So there is some losses, but very small amount of loss in the inductors. So, so the designed filter is reduced value of SIM inductor and components. Modified multi-stage EMF filter 1 has the benefits in long cable application, and modified multi-stage EMF filter 2 has a benefit in general with not long cable application, normal application. And both of them have a benefit in reduced volume and weight and cost in the CM inductor. So at high frequencies, all modified filters have a better performance. Okay. So now induction motor drive discussion is over. So we used DO160, which is used for aerospace applications. the standards. So generally, aerospace applications are having a higher stricter standard, because in air, if any disturbance happens, it would be a problem to the safety. So generally, aerospace has the highest strict standards for EMI. So now we'll go to the BLDC motor drive. So if we want, we can again ask for some questions. Anybody has any question until now? There is no question?
No, very.
Okay. So then we'll proceed. Huh?
Now we have discussed the EMI in inverters, is it? Inverters,
Yes.
inverters and the motors.
Right.
If suppose I am using renewable energy, I am using solar panel. With the
Right.
solar panel I am taking DC, and I
Mm.
am DC into a AC for inverter.
Mm.
What about the EMI problems in between that solar panel, the converter and the inverter? How to take or handle that EMI problems?
See, this is, see, power converter is there, obviously, depends on the source impedance or the load impedance. Where the noise will go from the source depends on what is the panel impedance to the common mode noise and the differential mode noise. Similarly, on the load side, say, let's say, whether the noise is going to go to the grid side much higher or on the solar panel side higher, depends on how different system is acting. See, one of the major problem with these all of these EMI issues is it's very unpredictable. Who is going to act like a much higher impedance, lower impedance, depends on even the small connections you make changes. So what is done is, in solar panel, separate common mode noiseless, so many configuration, transformer less, common mode noise elimination methods, all of them. So generally they use common transformer to isolate the noises, right? So people have to be careful in renewable energy applications. On the load side, in the grid side, there is standard anyway. Grid side, anything you connect it, you have a standard, like you have to anyway inject only 50 hertz noise in the grid. 50 hertz, I mean, not noise, 50 hertz content only in the grid. We have a THD limit for differential mode content, both voltage and current in the grid side. Whereas for solar panel side, yes, we need to make an effort to not, the noises should not go to the solar panel side. Yes, we should, otherwise it would impact the solar panel life.
And one more query. Suppose if you are using soft switching converters,
Right.
In that case, what about the EMI problems? How to tackle the challenges?
So in soft switching, there is much more chances that the high frequency noises would go down, because so soft switching, what does it do? It minimizes the rise and fall switching frequency component. So if you look at the bandwidth of the components, right? So maybe I'll show the results. If you see from the switching frequency, the noises, you can see differently the noise spectrum range. So this is the switching frequency. Then you have a switching frequency multiples, like your harmonics, right? And then this regions and all, they switch rise and fall time frequencies and then multiples, right? So what would happen? Definitely, if you use the soft switching, you will have a reduced noise in the high frequencies here around this region.
With the help of filter, we can easily remove that.
Yes. See, ultimately for soft switching, you're going to again add a passive components, right? It will act like a filter only for the high frequency.
Okay.
You see, maybe you might use the, some parasitic capacitances or inductances, but you still add the extra components.
Ma'am, is there an alternative solution for instead of using filters? Suppose if you use
Yeah, there are different methods. See, the simplest way anything, the product is made once or not product. When they are making the product, what do they do is they make good PCB design. So if you are making, while making the converters, what do? They make a proper layout of the, see how, what are all the sources if you are making the converter. One is the parasitic inductance, another one is the parasitic capacitances. If you minimize the loop inductance while making the converter itself, you minimize the dV by dt on the system. So this is done. So first you optimize through the design of the converter, how much ever maximum you can do it. That is done in the when they are selling the inverter to you, they optimize the inverter very nicely packed these things. They would study the EMI analysis and all with the inverter alone, and then they will give you. So when the inverter you are buying, obviously it is meeting certain standards, and then you go and install in the application area, say like you are connecting some motor. So then the motors will have its impact because it will have its own common mode impedance or differential mode impedance. Then that will draw different currents and different this thing. So to protect the load, then what you have to do, you have to take care of it. So now control methods are employed, as I said, in that will have an impact only in the low frequency region. See, PWMs where you can have a control only at the switching frequencies. You cannot go and control in the regions of rise and fall time frequency, obviously, right? So see, if I control through different PWM method, maybe I can reduce the switching frequency component to 100.4 to here. But all through the frequency range, it's very impossible to get the attenuation. So then the other methods, there are active EMI filter. What they do is, again, they use the switches and then combinations of, switches and then small amount of filter and capacitances, control methods, and then localized filter solutions only. So the most commonly used is the filters. Filter, because filter, if you see, it is dependent on the system impedances. Any filter you are inserting, you should have the common knowledge of the system impedance, because the capacitance, the moment you are inserting the capacitance, you should know how much is the system capacitance. Then only you can place the capacitances effectively, the values of the capacitance, right? So one is filter, another one is source control methods, either PWM control method or some other active control method by measurement, and then active EMI filters are there, and then passive EMI filters, and then otherwise they try to protect each and individual part, what are all the effects. Filter chokes are the commonly used method. In very low voltage applications, people were using some op-amp based solution. Very low voltage, it's not applicable for high power.
Okay. Thank you.
Yeah.
So continue PLDC motor.
Right. Okay. So BLDC motor, as the name indicates, brushless DC motor, it's similar to the DC motor. Here the purpose of commutation, commutator and brushes is replaced by here the converters. So the purpose of commutator and brush in the DC motor is to reverse the direction of the winding current. Sometimes if it is acting as the motor, or if it is a generator, it reverse the energy, right? If it is DC generator, then it will reverse the directions of the output voltage. So here in BLDC motor, you use the Hall sensor to know the position so that appropriately which field winding needs to be excited so that it can continue to rotate in the same direction. So the field winding, let's say I energize say A phase, B phase, C phase. A phase, I push it this side, and B phase, I pull it this side, the magnet, then obviously it's going to rotate in the same direction. And then again, what I do, I push it, come here, push it here, and pull this. And then two windings are basically excited at the same time. And then pull this, push this. So all three windings are sequentially rotated based on the sensing position. So three sensors are used based on the Hall sensors. The positions are sensed, then appropriate winding voltage is given. So basically in any one top switch and one bottom switch would be conducting at any given point of time. So it's impossible to control the motor without any converter. So it's part of the system. So if you see two phase only is conducting. So ideally, if you look at, so there were no much literature when we started doing research on noise in BLDC motor, right? Because their applications now increasing. So BLDC motors are now various applications. They are using UAV, drones, and electric vehicles and so on. And now the voltage ranges of these, all of the BLDC motor drives have increased a lot. And say previously, if you see 24 volt, 48 volt, less than 48 volt only, the BLDC motors were used. If you see the household fan, right, that is only 48 volt, less than 48 volt. Whereas if you see for an industrial application or pump application, it should be around 300 volt and higher. So this is the Hall sensor signals, and then how sector 1, sector 2, sector 3, sector 4, 5, 6, how the phase A is getting energized during what time, and how the phase C is getting energized. So this is the BLDC motor drive, normal informations, I mean normal operating conditions, right? So now in ideal condition, because we are exciting equal and opposite voltages on each two phases at any point of time, ideally we would say that common mode current is 0, because see, you are giving the top one switch here, the equivalent circuit. So if you see A to G, there will be a capacitance, B to G, there is a capacitance, C to G, the capacitance, but at any point of time only two capacitances are acting, and therefore ideally I can say the current through the common mode or the ground is 0. Whereas if you see, the switches are not going to rise and fall equivalently, and therefore non-ideal rise and fall current. And then what the literature said is this current is non-zero, so they have come with some active compensation method to minimize the common mode current noise. What we did is first we were not agreeing with this argument, only two phases at a time noise also will flow. It might be the conduction happening in the between the only two phases, but noise, even there is a small amount of glitches there will be a noise in the circuit. So we wanted to verify that. So what was the initial idea is to address the CM issue for the higher voltages, and then understand the EMI generation first, whether it as it is whatever they have said is happening. And there are very complex active sensing based method was proposed in the system. So we thought whether employing the filter itself is the simplest option or something else we can do. So first we wanted to investigate the CM noise with 120-degree commutation. This method of commutation is called 120-degree, right? And the analysis of both propagation path of we want to understand the complete noise profile, sources and everything. And there is a floating phase at any point of time. Only two phases are conducting. There is a floating phase. We want to understand what is the floating phase effect and validate the results through the experimentation, right? So what we did, we measured the common mode noise. So this is the method of common mode noise measurement. So you short all three wires, positive you give here. frame you connected to the other line. There are two lines. Between the two lines, you measure it. Automatically, they will formulate some parasitic capacitance inside because you are going to sweep the frequencies through this impedance analyzer. So now this is the impedance profile of the common mode noise. I mean, common mode impedance profile of the machine, right? So you can see here there are different resonances occurred. So what we did, we predicted the this network impedance. We constructed, basically we synthesized the impedance into a network. We called this as the dummy parasitic network. So this slope decides the capacitance. Then this resonance will indicate L and C, because I know already capacitance, find the L, and then F2. Similarly, I know the resonance, I know the slopes and so on, right? So then we found out two inductances and two capacitances, and then this point will give you your resistance value. So we called this as the dummy parasitic capacitances. What we did, we inserted this ZAG, ZBZ, ZCC just outside the machine. This is called dummy parasitic capacitance. So we inserted the DPI network here. So you can see if they are equal impedance, what would happen? The same source, if it is facing, half the current will come here, half the current will go here, right? So then what we did, we measured the common mode current inside the machine and outside the machine. See, inside the machine, we don't have an option to see it in each individual phases. The purpose of going for this dummy parasitic network, right? We cannot access this. So now if you see, the noise profiles of both of them are almost same. So then we can say that this is acting similar to this. So now now what is done, right? So now what we did, so we then analyzed individual IAG, IBG, ICG of this dummy parasitic capacitance to see whether floating phase is having the current. So we verified that floating phase is also having the common mode noise. So what we did, we measured all of this IA, IB, IC. We have the sector sensor information to identify the sector. We also know and which phase is conducting and under which sector. Then we summed up, and then we say this is CM currents due to conducting phase, and then we measured the overall common mode current, that is the normal common mode current. So this is all three phase conducting noise. This is only conducting phase if we segregate. So we are able to justify the floating phase is contributing to this much amount of noise. Right. So because what we found out in the floating phase, there is some high frequency noise oscillation is happening because of we call that as mutual inductance and coupling effect between each phases. So there is a dV by dt in all three phases at a time, even though I just want to show it. If you see here, see the phases which are switching is only VAG and VBG, but even VCG is going through a change, you can see here. So even though two phases are going through the this thing, conduction non-conducting phase is also having an oscillation. Basically, if there is a dV by dt, the capacitance, there will be a current. So this we verified through analysis. We verified through the analysis that conducting phase is contributing to the floating phase is contributing to the CM noise, and then we employed some simple solution, and then to attenuate the CM noise, mainly in the SIC inverter based BLDC drive. This is one of the work we have done, and we have done some more analysis and this thing in the later, but these are all the equipments we were having it some in the lab, and these are all the references used. Yes, any doubts, questions? Yes, please. Someone is raising the question. Raising the hand. Yeah, please.
Please unmute yourself and you can raise your.
I think Dr. Manish is raising the hand.
What do you mean by the floating?
Floating phase is non-conducting phase.
So how you are creating the floating phases?
We are not creating anything. Basically at any given point, it's an operation of a BLDC motor. At any given point, there are 3 windings are there. Only 2 windings are going to conduct. That is how you are going to push and pull the magnet itself. That's an operation of a BLDC motor.
Okay.
One of the winding will not operate.
Okay, thank you, ma'am.
Yeah.
Any other?
Please share the slide with us, ma'am.
Yeah, sure. Yes.
Any other questions from participant side? Participants can unmute yourself and you can ask your questions.
Yeah. Yes.
Yes,
I cannot hear, I think. Somebody is speaking?
Yes, ma'am, he is having a network issue.
Kindly proceed, ma'am.
Yeah, yes, I think that's all the presentation I have prepared. Any other questions, or we can have some discussions if you want.
Any other questions from participant side? So thank you.
Yes, thank you.
Yes, ma'am. I conclude, ma'am.
Yes.
So it is a privilege to have an opportunity to deliver the vote of thanks for this insightful session. On behalf of the management and Department of Electrical and Electronics Engineering, I would like to express our sincere gratitude to Dr. J. Kalachavi Madam, Assistant Professor to IIT Ropar. The ma'am has given a comprehensive understanding of the quality control and assurance and detail about the EMI issues, induction motors and BLDC motors, etc. We are truly grateful for his valuable time and knowledge. Lastly, a special thanks to our esteemed audience and for active participations and engagement have greatly enriched this session. Thank you all once again. Thank you, madam.
Thank you, sir. I'll share the slides in this thing.
Okay, ma'am. Thank you, ma'am.
Yeah, thank you so much. Yeah.
Dear sir, madam, please stay online. The next session will start within 5 minutes.
Sir, good evening, sir.
Good evening, Raja sir.
Yeah, sir. Good evening, sir.
எப்படி இருந்து நேத்திய ப்ரோக்ராம்?
Nice, sir.
ஓகே. என்ன இண்டஸ்ட்ரி 4.0 and 4.5 வந்து இட்ஸ் லிங்க்டு ப்ரோக்ராம்.
Yes, sir.
மேபி கொஞ்சம் முன்னாடி இன்னைக்கு வைண்ட் அப் பண்ணலாமா?
Yes, sir. Session வந்து 5 to 6:30, sir.
6 o'clock வைண்ட் அப் பண்ணிக்கலாமான்றேன்.
Okay, sir. 6:10 அந்த டைம்ல வைண்ட் அப் பண்ணலாம், sir.
ஓகே சரிங்க. 6 o'clock வைண்ட் அப் பண்றேன். ஒரு 10 minutes கொஸ்டின்.
சரிங்க சார். ஓகே சார். Sir, we start at 5 o'clock, sir.
I will start at 5.
Okay, sir. Thank you, sir.
கிளம்புங்க போய் ரெஸ்ட் எடுத்துங்க. 9:30 வந்துருங்க.
வந்துட்டு ஒரு half an hour மட்டும் earlier முடிச்சிடலாம் அங்கிள். 3:30க்கு முடிச்சிட்டு வேணா நாங்க இங்கதான் அங்கிள் மெஜஸ்டிக்ல 4:15 அங்கிள் ட்ரெயின்.
ஓ அது வேற இருக்கா?
ஆமா, அதனாலதான் காலை கொஞ்சம் ஒரு half an hour earlier பண்ணிடலாம் அங்கிள். இல்ல பட்டு 3:30க்கு கரெக்டா பிரேக் விட்டுட்டு அப்புறமா கூட வேணா.
Good evening, everyone.
Sir, good evening, sir. Will we start now, sir?
Yeah, we can start.
Yes, sir.
Good evening, everyone. Thank you for joining us on day 5 of the ATAL sponsored faculty development program on Design for Manufacturing and Advanced Automation for Industry 4.0, organized by the Department of Electrical and Electronics Engineering, STEAM, Manappuram Engineering College. We have had an enriching journey so far, and today we continue with another exciting session. Now, to formally introduce and invite our guest speaker, I would like to request Dr. D. Sivaraj, Assistant Professor from the Department of Electrical and Electronics Engineering. Thank you.
Thank you, sir. It is my honor to introduce today's distinguished resource person for the ATAL sponsored faculty development program, Dr. Pannisalvam Ramaswamy, sir, Principal Director, MSME Technology Development Center, PPTC, Agra. With over 2 decades of experience, Dr. Pannisalvam Ramaswamy has a strong track record in the implementation of ISO standards such as quality management system, environmental management system, and occupational health and safety. He is also highly proficient in Lean Six Sigma methodologies, which he has applied to enhance process efficiency and foster a culture of continuous improvement across industry. Additionally, SAR as central committee member in the implementation of Industry 4.0. So beyond his technical expertise, SAR is deeply committed to an entrepreneurship and innovation, playing an instrumental role in bridging academia and industry. He has successfully mentored several startups, particularly in the field of engineering and technology, and has been a driving force behind numerous skill development initiatives aimed at equipping students and professionals with competence required for the future workforce. SAR contribution to teaching and curriculum designs have also been pivotal and has played a key role in developing programs that integrate entrepreneurial thinking with technical expertise. His work as a data analyst further amplifies his ability to solve complex problems and lead innovative projects in both academic and industrial settings. We are privileged to have Dr. Pannisalvam Ramaswamy sir with us today, and we look forward to benefiting from his insights and extensive experience. I hand over to sessions to sir. Welcome, sir.
So, thank you very much.
Thank you, sir.
Am I audible?
Yes, sir. Yes, sir.
It's my presentation is visible.
Yes, sir. But slide will be zoom in access, sir. Make the slide to fit to screen, sir.
Slide is visible.
Yes, sir. Visible, sir.
Visible, sir. Shall I go ahead?
Yes, sir.
Okay. So thank you for the wonderful introductions, short and sweet. And as I told yesterday, today also I repeat the same thing. Yesterday, one point was missing. I was the member of implementing committee and the member of a task force committee for implementing Industry 4.0. But and now no more. I am a member. Now that has been, because I have retired, I no more a member. But I was a member of the implementing committee because it is a 3-member committee set up by the secretary MSME. One joint secretary headed the committee and the director was there, and I am the former principal director of MSME Technology Center was also a member. We have submitted the report to the Government of India. Now, subsequently, there was a COVID, it was left out. So I don't know the actual position now. Now I no more the committee members, but still. So we have done elaborate research. I have an idea on the Industry 4.0. So yesterday I was mentioning about the Industry 4.0, but the new technology now emerged is, industry 5.0. That means 5.0. Fifth industrial revolutions. So when you see how fifth industrial revolution has started, it is now human-centric, sustainable industrial revolutions. Human-centric. The center of this one is focus is human, involvement, sustainable, resilience. This is the things that included with the industry 4.0. Industry 4.0 as it is there, but other things got added up. Suppose we can for example, so we are everything is automated. So yesterday I said, there are a lot of other technologies involved in industry 4.0. It keeps the entire production is automatic. So I was just mentioning about the extent of 4.0. That means industry fourth revolution to fifth revolutions. Because when it is completely automatic, you can't have anything which is going wrong in case of even suppose some harm to the environment. That's what I was mentioning. So the continuous productions will go on produce some wrong defective products, and we'll be wasting our energy, time, and then money and waste product, and also harm to the environment. So suppose some product we can imagine which is not suitable for our the present day lifestyle. For example, there are a lot of things have happened with the mobile phone. Yesterday I was talking more about the mobile phone. So all started with the pager, then pager 2, handheld mobile, and then the bigger one, and then slowly it started. Then it comes to the smart, smartphone now. So suppose the product, product also in course of time changes, many changes. We need to accommodate the changes, and the technology changes, lifestyle changes. There are many things we have to accommodate in the production at a service process. But in the case of automatic, manufacturing like industry 4.0, it will go on produce certain things even when something goes wrong. So you will not take into consideration of the latest technology, latest the lifestyle, the latest working way of people. So it's completely replaced by the human. So human has got no value, to no role to play. So it's get automated everything. So in the course of time, you are likely to produce or harm to many people. So maybe in the case of harm to the environment, harm to the people, maybe accident harm to the business. So we will have a lot of things. Then business cannot survive. So how to bring the sustainability in the business? How to cope up with the resilience in the business? Cope up with all those changes that's happening and come up. And then people, come up with an idea that so human-centric is the only solutions to understand. So the automation and industry 4.0, it cannot replace the human, but it cannot replace the workers, but it can, it can assign them the it can assign them the other roles to play. It's not that they should play the roles they were playing, but they can think, creativity can, bring in the business, bring in the process, bring in other, type of process, the business processes. That's what the industry, human centric of the industry 4.5. So 4.0 as it is exists. But now we want alongside of the automations, people also. That's what the human centric, sustainable industrial revolutions. So when you talk about 5, then definitely we have to talk about the industry 4.0. 4.0 is as it is existing. Only it is a collaboration between the human and advanced technologies. So emphasizes on sustainability, resilience, and human-centric approach. That's what altogether industry 5.0 means. But the objective of this presentation is going to be just see the principles and technologies and opportunities for industry 5.0. So it is something like improved version of 4.0, improved version of 4.0, that the 4.0 as it is exists. So when you see industrial revolutions, it's all yesterday also I mentioned. So it's all started in the year 1784 with mechanical looms designed by the English inventors, steam engines, and cotton spinning, all those stuffs. And then in 1870, the second industrial revolutions, so the conveyors and motor electricity. With the use of electricity, we invented a motor, then it became automatic. And now telegraph, rail network, gas and water supply come into picture. Then 1969, third industrial revolutions with electronics and mechanical digital technology. So mainframe computers, telecom, personal computing, so internet, and research and biotechnology. So many things have come into picture. 1969. So we are all present, most probably, many of us witnessed the third industrial revolutions. But today we talk about the fifth industrial revolution. It is an extent of a fourth. What is the fourth? Fourth is involved with the technology and completely automated manufacturing productions. So, or a service business. For example, when you say with a lot of technologies, so it involves technologies like big data, IoT, industrial Internet of Things, 3D printing, and the cobots, and mobile computing, and robots, and the many other technology, virtual. So, like this, there are many technologies involved in the process. Virtual technology, augmented technologies, there are many technologies. So, fourth revolution saw that completely avoiding human approach, making it complete, automation, complete automations. So the complete automation brings a lot of other difficulties. That's what I was mentioning in the beginning. So when you say how it is done, the fifth revolution and the fourth revolution, the stages of the fourth revolution never changes. But now we are going to add a human approach. So along with the machineries, we will also have, human in between, a work along with the machineries. So we'll talk to the machinery, communicate to the machines, and communicate to the technology, and collaborate with other technologies, and see that, you know, so give the input of creativity to the point of, human-centric approach. Whatever the AL and ML do, that no man can extend that. Man can extend such technologies. Now that's why AL and ML has come in. So most probably it goes in the same directions. Goes in the same directions. So when you see these stages, it's all same. Fourth revolutions. Up to fourth revolution, it is the same. Computerization, connectivity is the first stage. Digitalization. Computerization, connectivity. That's why when you want to automate anything, we should first do the computerizations and then connectivity. So we should interconnect the machines, interconnect the plant, interconnect the operation, interconnect the business process, so that you can have a visibility. So make it visible. Make it visible. That means you will be able to see it. You'll be able to see the things, what's happening. Then you will also see the things are being analyzed and understood. Analyzed and understood, and then being prepared, predictive. So that means when you have analyzed, then you will come to know what goes wrong, what comes in. So you will clearly say that, is there any problem with the process? So that's what, so you analyze and find out what's going to happen. What's going to happen. Then take a corrective actions. So act according to the analysis, what it can bring, take a corrective actions. That's what the digitalization journey for Industry 4.0. The major technological involvement involved in the technology 4.0 and also the same in the 5.0 is the robots, simulations, devices, and then you can see Internet of Things, cyber security, cloud, additive manufacturing, augmented technology, reality, and virtual reality, big data analytics, and robots. There are plenty of technology, a lot of technologies involved. But now, instead of Industry 4.0, it got everything. Now you come in the center. Suppose imagine you put someone inside the center, so you will take care of everything. So it's not going to replace his creativity. You will oversee things and take corrective actions wherever the corrective actions are required. So suppose something goes wrong and produce which is not good for the environment, so the human creativity can take corrective actions. That's what industry, the technologies centric human approach, human centric approach. So the key issues in the ministry is now the manpower. So idleness. So many places we can see people sitting are idle for many things. Maybe raw material shortage idleness, or waiting for the next process. The previous process, and skilled people are not there. So there can be many reasons for manpower, and then machine improved capacity utilizations. To bring a better utilizations, we can use. That's always remains a tough for key issue for any productions or a service oriented businesses. Material tracking. Of course, material tracking and order at the right time happens with great difficulties in the business. So the technologies definitely will help to track the material. So maybe right from the beginning, so then to finish the product, even after putting it to service by the customer, we can have a tracking of items. The method, innovation in design. So the taste in course of time, the taste also varies. People change the taste in course of time. So it depends on that. See, the technologies can help to improve the efficiency, maybe energy efficiency or operational efficiency, whatever it may be. So then the quality builder in the quality system to reduce rejections. So that's a big, you do anything, everything, but the process improvement was not part of a quality management systems. But now the process improvement with the technology brings process improvement. That the real, the Six Sigma, through that you achieve towards zero defect, zero error, zero mistakes. So that means any quality system is not bringing any improvement in the rejections, whereas the process improvement through the technology can bring towards zero defect, zero error, zero mistakes. And then marketing, improve visibility at the reduced cost. We can see the market with the technology. We can analyze analyze the marketing. Then we can take a corrective actions to give right product and the right service at the to the customer. This is possible with the improved technology like today's digital marketing gives a lot of improvement. And then see government regulations. Now and then government changes the regulations. Somebody has to watch on the regulations and then take corrective action and also fulfill those things. The technologies can help to track such regulatory or guidelines and then take corrective actions. The money visibility of finance. So that's a big, see, any business, we are doing maximize the profit. So when we don't know, so we are not at the mercy of accounts. So it's a great difficulty for the business. So we need to have a clear idea, visibility of financing cost. So and maximize the profit is big, a competitive edge. So the technology is definitely going to change those things. So the profit, yesterday also I have shown this slide. So how the same thing with the industry 4.5, most probably it will increase other, efficiency of energy, efficiency in the environment management. All those things can be part of industry 4.5. So increased productivity is there because we were discussing the extension of 4.0. 4.0 is the extension. So 5.0 is the extension of 4.0. So whatever the benefit that you are now achieving, in the case of 4.0 is very well, you can aim for 5.0. So increase productivity, provide better data. So I think it is 44%. It's a great advantage. Increase competitiveness 46. All 40. The minimum is 6. 6. And again, so others 20%. Lowest staff cost. Increase the product customizations. Increase the factory. Save. and increase innovations. You can see 35%. Increase in process capability and profitability. 42% increases. It's a great amount. 42% no one gives me. I know for any type of a business. So the profitability is around 20%. Now you can see up to 42%. Lowering manufacturing cost is 44%. No increased competitiveness 46. So we have a great advantage benefits for industry 4.0 and also the extension and 5.0 with the proper involvement of human centric. So the transition from 4 to 5, it takes with the technology. 4 is automations, other technologies like Internet of Things, big data, AI and ML, AI, artificial intelligence and machine learning. Whereas Industry 5.0 is enhance the Industry 4.0 technologies. That is, these technologies at the center is the human approach. So the focus on personalized production and human creativity and integrate the sustainability and ethical considerations. So that's where the transition takes place. 4.0 is full of automations, full of technologies. But 5.0, we can't say that's full of technology, but you are not replace the manpower. You have a manpower along with the technologies. So focus on personalized production and human creativity. So, and then integrate the sustainability and ethical considerations. So this is what the transitions takes place, 4.0 and 4.5. So key features, again, it is a human-centric collaborative robots working alongside the human. That's what I said. So you work along with the humans. We don't know what it's going to produce. So we have seen the good, picture. So even in cinema, you can see the people, what will happen when, you produce robots. Robots will, will obey on such a kind of order. It can bring destruction to the societies. But when human work alongside, so you can correct the robots. It can correct the robots so that we'll have human approach. That type of things will not happen. And then sustainability is a circular economic model in the carbon footprints. That means we keep environment intact. You will not spoil the environment for the benefit of making a profit. You make profit, of course, automatic. You produce mass, and when you take care of environment, then you will produce a mass destruction also. So from that, we take a corrective actions with the human involvement and assess things, and then put out the human creativity and see that sustainability happens. So adaptive of supply chain and robust system against the disruptions. So this is many things happen in course of time. See, for example, COVID, no one expected. So it changed the entire business. The new type of a business picking up now. New model is coming. So it's some sort of, new avatar, for a business and the business services. So even with all the things, some businesses are still existing, are doing better. So you should have such type of, resilience. So resilience even after, technology change, raw material change, material supply change. So the many change, it gives the robust systems against disruptions. With all these things withstood some industries, they are existing. For example, many Tata consultancies, Tata, services and products still exist. No disturbance for the systems. And leveraging the AI and advanced technology for personalized solutions, the innovations you can give now, you are personalized solutions for customer, and so you use human brain and to see that you take leverage with the help of artificial intelligence, so advanced technologies, to ensure the personalized solutions. We try to give personalized solutions. Circular economy, how it works, you can see here. See, I just, this slide is not the usual slide which I sent. I had it, this slide. Raja sir, after submitting the presentations to you for, I have again, added little changes to the presentations. So this slide I thought will have, some clarity. So you can see here, the raw material comes to design, production, so the reuse, disturbance, so reuse or use residual waste and recycle it. Again, the raw material goes like this. So circular economy happens. That means reuse is main issue, and circulating the same thing, over and over again. How many times you do it? Circular economy. And resilience, whatever happens, we will withstand in the business. There are many things can, disturb your business, but we can, social factor or your, emotional factor, and, see your belief factor. There are many disturbances can happen, but still you remain functional from the cost perspective viewpoint. And then innovations. See, innovations, you have, many things. It's just an example I have given again. So significance, executions, and creativity. So the center point, which is, the intersection of all three, execution, creativity, it involves execution, creativity, and significance. That's where, the innovations comes into picture. So this also possible because of human-centric approach. Technology is driving the industry 4.0. This is all technologies which are there for industry 4.0, or the same technologies will also carry the industry 5.0. So here artificial intelligence, robotic, IoT, edge computing, blockchain, transparent and secure transformations. This is some additions side. Even this also there in the 4. And again, renewable energy, this may be, addition, integration of green technologies, and then 3D printing, customized and localized productions, 3D printing. 3D, now we have gone to such an extent that any, material you say you can 3D print it. Even people started, making a ready-made Italy machines, dosa machines, 3D printing, using 3D printing. You can print the idlis, you can print the dosas, you can print the chapatis. So that type of a customized and localized things can happen, change can happen. And artificial intelligence, of course, So it's a machine learning using a simple data to train computer programs and to recognize the pattern, based on the algorithms, and neural networks, the computer systems designed to imitate the neurons in the brain. Yeah, it works like a brain. The natural language, the ability to understand the speech as well as understand the analyzed documents. So, and then robot, the machines that can assist people without actual human involvement. So, this is a technologies possible using artificial intelligence. Edge computing, again, Internet of Things, edge computing and the cloud, CB. See, you store everything in the cloud now. Real-time data processing happens in the edge computing. So you get a lot of data and you analyze the data on a real-time basis, then store it in the cloud. So blockchain is another technology. We can, it is something, it works like as a ledger, but it gives the informations to all the system integrated in this network. So you can see A send your money to B, it goes, bitcoins. I think with the changes in the US, most probably this technology will pick up, it seems. So broadcast to every party in the network, every party. So every party knows that this money is going from A to B and then added to the blockchain. That means you add this in the blockchain. This means it's got entered and it is known to everyone that this is what happened in the systems. Then money moves to A to B, A to B. So it informs everyone in the systems and then it moves to the right persons. So you can see here, everyone in the system approves, give tick mark, and then it moves. The human-centering approach ultimately, it gives empowering the workforce through advanced tools. So no longer you need to take over, very, very odd jobs and difficult jobs where, the people work in the forging and foundry is not required. Forging, foundries with a lot of heats. So enhancing creativity in innovations. So now it happens that the people are replaced by the robots. It's not replace the work role, but it is replaced only the activities performed by the humans. Now workforces, now you have enough time to have a creativity and innovations. Focusing on improving workplace study and safety. So workplace study and safety, you have the humans can have more time on this. The safety can avoid many risk factor and you can take corrective actions. And personalized customer experience also can bring this human approach. Sustainability, I already, I gave some examples on this. So renewable emphasizes on the renewable energy sources because when you use the energy, you bring harms to the environment. Renewable source of energies are plenty available. So in the countries like us, India, we can easily, use the renewable source of energy so that harm to the environment is stop. Adoption of circular economy principle, reduction of waste through intelligent manufacturing, and design of a product with the customer in focus. Customize the product. And challenges. But what are the challenges? So even with the human centric, we have a lot of challenges. Resistant to change, yes. So all people will have this resistant to change mentality. So the high cost of technology adaptations, it's not happened in India because the technology involved takes a lot of money, high cost. So we cannot afford to have high cost, but whereas we can bring employment to our people. So that's why wherever there is a technology is required, with the high cost are replaced by the low cost employees. So skill back in the workforce. So we have a lot of high technologies. We do not have a people. So skills upgradation, no skilling is happening across the country, so that across the globe. So that's a big challenge. But the data security and ethical concerns, that's another big problem. And so even in our telephone, and we are getting the message that so be careful of your security, data security. So people can misuse. So be careful. So that's what we are getting. Every call you make or a call you get, generally we listen this messages. Solution. So continuous workforce training in industry 4.0 or 5. 5 is the extension of 4. So we should get into 4 and then 5. So systematic investment in technology. So as you've seen, the first step is computerization. We should do computerizations and then connectivity, then go for other stages. So implementation of the ethical artificial intelligence framework. So this is another big area where you can, because of the artificial intelligence, it can take care of certain things in a longer run. And so it can understand, it can, learn and then act, So collaboration between the industries, government and academia. So government should come out with a lot of schemes, a lot of, ideas how to implement these things. Now, so far, we do not have, because certain time, government will not have a funding for development. So we'll have for essential things. So that's what happening. Collaboration between the industry, government and academia. For example, we have, I have seen a beautiful, very wonderful training setup, at Osor, all financed by industries. It's a government support. With the government support, they establish the training center. But trainings are not very, very much happening like they need, industry needs, particularly for MSME sector. So only the collaborative industries, they take advantage of the existing facilities. So some things should change. It should be made available to everyone and who are interested to take, skilling. These are the 4 biggest challenges, and solutions are continuous workforce. Even and with our colleges should aim to put a training for all the developed technologies, so that can take care of certain amount of workforce engagement. Then future trend it is that it's a greater interaction of AI with the human connectivity. The future trend. So we are going to most probably, you will sit with the robot and have your food, or you can talk with your robot and you can have food. The food robot can serve your food. So no, I am just, and in the lighter way, I am put it like this, because we are going to work along with the automations, robots. So without robots, most probably now the life is without a phone. Similar things may happen. Without robot, there's no life. So that's one area, greater interaction of AI, intelligence, artificial intelligence with human creativity, and expansion of sustainable manufacturing practice. So, of course, the USA has come out of French agreement, but there is a lot of agitations, maybe across the globe, that it's not correct. So we should, follow the sustainable manufacturing practices. So then enhance the focus on ethical consideration and technology. So ethical considerations will be another bigger challenge. So enhance the focus, but they are going to focus one step ahead, but still you will go again one step further. So growth of adaptive and the resilience supply chain. So supply chain now completely changing, just in time, because you have a lot of process improvement, and you will see process improvement is happening continuously. So we will, have a very adaptive, resilient supply. When you're ready, you pick up. When you want, you acquire. That means you take. That's why nowadays, I know it is a very common sight. So to many people who have come across Bangalore to, Bangalore to Chennai highway, there are many vehicles parked outside. They're just to pick up things or deliver things. This is because of the want of time, they will be waiting, because they are not allowed to inside because of just in time. Because adaptive and resilient supply chain. So then advancements in biotechnology and human adaptations. So biotechnology advancement, maybe we have used our artificial intelligence, and human augmentations. So come out with a lot of R&D efforts. So many good things can come out. So these are the trends that's expected in the years to come. And the call for actions. What actions that colleges or the government has to initiate? Embrace the human approach in your organizations. That's what we have to do. Is put your robots along with the people. Along with the people, invest robots. Invest in sustainable technologies and practice. Sustainable technology has become a big issue. So because of that, our temperatures also rising. We get a lot of rains, uneven rains, uneven climates. Many things are happening across the world. So invest in sustainable technology and practices. And upscaling the workforce for future network. So not just taking a degree is not sufficient enough. Now anticipating a lot of technology, upskill should happen. So the skill and upskill, the present workforce should have. So then only you can, cope up with the technology developments. Then collaborate with the innovative solutions for global challenge. We can collaborate, with the innovative solutions. Because your work, robots going to. So you have more of time for a creativity. So that's what we have to innovative solutions for a global challenges. see, conclusions, the industry 5.0 represents the next step in the industrial revolutions. Because we are all going to, the world is going to now focus or witness industry 4.5 solutions. It will focus on human and machine collaboration. That's what I said. So you will have machines working with the man, working with the man. You are suppose already there in the many places. I gave an example yesterday. So when I went to Syria, Korea, South Korea, so we could see robots moving around the airport, so guiding people. So there are a lot of focus on the human and machine collaborations, sustainability and the resilience. That's what's going to happen. Then offer unparalleled opportunity for innovation and growth. So people, every hard job is taken care of by robots. So what man will do? Man will have a lot of opportunity for innovations, creativeness, and growth. So that's why now things are changing. You get very, very innovative products, and the future is a collaborative and sustainable one. Maybe, so a lot of movies are coming with robots getting involved in the human life. The same thing is going to happen. Most probably everyone, those who happen to have a robot, most probably will have a robot in our house. Like purchasing TV for our day-to-day entertainment. Maybe we can have robots for our assistance and sustainability. So this is going to happen with the Industry 4.5 solutions.
Any questions from participants?
Sir, our questions, sir. Sir, good evening, sir.
Hello.
Sir.
Yeah, anyone can. I think today also Manish Kumar is there. Dr. Manish Kumar ji, you can go ahead. Satya madam, you can also go ahead. I think, sir, you have to unmute them. Allow them to unmute and speak.
Already given, sir. Permission given, sir.
Permissions given.
Yeah.
So please unmute and speak.
Hello, sir.
Yes.
My question is regarding simple that we are still in a verge of going to the industry 4.2 in full flow. So then how much it will take time to be realistic to be in industry 5.2?
Oh, not only in India, yesterday that slide was there. Almost everywhere across the globe, it is the same. Not in India. The same positions. We are in stage 2. Most probably it will take another 10-15 years to get into those stage. So generally our advancement, it takes 5-10 years to come into India. So it may take 5 years, maybe 5-10 years. But we are seeing the development now in even MSMEs. Yes, Satya madam.
Satya ma'am.
Sir.
Satya madam, you can.
Sir, how can education institutions and industries, how can education institution and industries collaborate to prepare the workforce for a transition of industry 5.0, sir?
So a lot of schemes, lot of programs are with the MSME Technology Center. So what I suggest is you should see, I don't know how you identified me. So you should do the same thing with technology center collaborations, and you should develop a lot of high upskilling. College can do upskilling. So college can get revenue for the idle infrastructure. Definitely, some colleges will have high-tech machineries. For example, 3D printing, CNC machines. This is all idle in many places. So the colleges should take advantage of taking utilization of the infrastructure available with them and help industry to upskill them.
Thank you, sir.
There is a question in chat box, sir.
There is one question from Nageshwaran.
Yes, sir.
Venkateshwaran.
Venkateshwar.
Yes.
How to manage manpower in Industry 5.0?
How to manage the manpower industry? See, Industry 5.0. It's not going to have something. So our aim is to just look for creativity among the workers. Maybe the difficult jobs are done by the robots. So man can give creative outputs. So you should have a separate, yardstick for, measuring the performance of the, workforce. So that way you can do it. Most probably the college can help in upscaling the workforce with the latest technologies. I think Satya Madam can take one more. Satya Madam, you can raise the questions.
Any other questions from participants? No, correct.
Any other questions? Yes.
Any other questions from participants?
Sir, good morning, sir. Good evening, sir. Hello.
Please, sir.
Sir, can you hear me?
Please,
sir. What are the requirements for 5.0 for the skills? What are the skills required for the industry 5.0?
Can you repeat, please, Venkateshwaran sir? Dr. Venkateshwaran.
Sir, what are the skills required for industry 5.0, sir? What are the skills to develop the 5.0?
See, almost all the skills are required. To start with visualization, computerizations, IoT, your big data, analytics, data science, all those artificial intelligence, machine learning, deep learning, this all college can bring in, upscale people, So,
okay, thank you, sir.
Thank you. Still, madam is there? Vidya madam? No? Now, see, raise the hand. Sir?
Sir, ma'am? Any other questions? Can we conclude the session, sir?
Hello?
Sir?
Yes?
Shall we conclude the session, sir?
Yes, we can conclude. We can conclude because yesterday I gave extensive
So used to it. I say good morning. I work in location. Sorry. Good evening. Good evening all. Yes, sir. We are one few. Sarana Kumar. I prepared FMEA, okay, but I didn't, I was not.
Hello?
Sir.
Yes. We can conclude, I think. There is
Okay,
no more questions, we can conclude.
Okay, sir. Okay, so thank you for your informative session towards Industry 5.0, sir. Uh, uh, at this juncture, I would like to invite Mr. K. Tangaraj, Assistant Professor, Department of Electrical and Electronics Engineering, to conclude the session.
Good evening, everyone. As we come to the conclusion of today's session on towards Industry 5.0, I would like to take this opportunity to express our sincere gratitude to everyone who contributed to making this session both insightful and impactful. First and foremost, I would like to extend our heartfelt thanks to our esteemed speaker, Dr. Pannirselvam Ramaswamy, Principal Director, MSME Technology Development Center, PPDC, Agra, for his remarkable presentation. The way you have articulated the shift towards Industry 5.0, emphasizing the synergy between humans and machines and its potential to reshape industries, has left us with valuable perspectives. Your deep insights into the future of manufacturing, AI, automation are truly inspiring and thought-provoking. A special mention goes to all participants for your active involvement. Your contributions have enriched the sessions and added to the depth of our collective learning experience. As we move towards the future, the knowledge shared today will undoubtedly serve as a stepping stone for all of us in adapting to and contributing to the exciting world of Industry 5.0. Thank you once again for being a part of this enlightening session. Thank you.
Thank you, sir.
Thank you very much. Thank you. I will leave the meeting, sir. Raja, sir.
Thank you, sir. Thank you, sir. Participants are kindly requested to start your video so that you'll be taking some screenshots. So turn on your video. Please turn on your video so that we'll be taking some screenshots.
Sir, admin can enable the video, sir, first.
Yeah, please. Few minutes.
Host has disabled the videos settings, sir.
Same here, sir.
Yeah. Now you can do it, sir.
Yes, sir.
Able, sir. You can turn on videos so that I will be taking certain screenshots.
The participants are kindly requested to turn on your videos.
Thank you, sir. We'll be sharing certain details. You need to fill the feedbacks for day 6, as well as you have to fill the feedback in ATAL portal. That also will share it to you. In addition to that, you have to take the test in ATAL portal. So you have to log in. I think the question is enabled. The test probably will start by 7 p.m. and it will end by 7:40. 7 to 7:40, the test will be enabled. So you are kindly requested to complete the assessment. So all details we posted in the link as well as in the WhatsApp group. So kindly complete. If you have any queries, you can raise. It will be ready to help you.
Hello, sir.
Yes, sir. Yes, sir.
Sir, I am unable to log in a ATAL portal from my laptop. So, because it is not taking captcha, so I was unable to log in the ATAL portal.
So you can also log in through mobile, sir. We will share all the details, sir. We will share all the details.
Okay.
And if few minutes, sir. Sir, ma'am, so if you want to convey any oral feedback, now you can unmute yourself and you can convey your message, oral message to this 6-day online faculty development program. You can unmute yourself. If you want to say a few words, that is feedback, oral feedback about this FDP, you can convey the message.
Sir, good evening, sir.
Good evening, sir.
This is S.T. Shekhar from RMK Engineering College.
Yes, sir. Yes, sir. Please, sir.
Yeah, all the sessions were very much informative and useful for us. Especially, we want to thank you for that timing you have fixed from 6 p.m. to 9 p.m. It was very flexible for us and it doesn't disturb our academic classes also. So I thank on behalf of everybody to the entire team and the AICT person. Thank you. And ATAL team. Thank you, sir.
Thank you for your feedback.
Hello, sir.
Yes, sir. Yes, sir. Manish Kumar, sir.
Dr. Manish, working in CPET Jaipur, did my PhD from IIT Hyderabad. So you have connected very nice, this FTP in very nice manner.
Yes,
and giving the PPT on a time. This is very helpful to the participant to take active participation in the assessment.
Yes, sir.
Okay, thank you, sir.
Thank you so much, sir.
Good evening, sir.
Ma'am, please, ma'am.
This is Priya from NIT Puducherry.
Yes, ma'am.
First of all, I would like to thank the management, Manaklavanaikar, to arrange such kind of FTP. So it was well organized and the resource persons were very knowledgeable. Actually, we didn't expect these kind of knowledgeable persons, but they were really very good, sir.
Thank you, ma'am.
And all the sessions are very nice, sir. Thank you once again, sir.
Sir, good evening.
Good evening, sir.
So this is Durirajan from Anna University, Kanjipuram.
Yes, sir. Please, sir.
So I must congratulate this time to the Department of EEE for getting and organizing such a wonderful FDP for the past 6 days.
Yes, sir.
So one thing I want to say here, normally in FDPs, so most of the resource persons will be from only the academic institutions. So this is the very first time I heard that the mixed from industry as well as academic persons. So both in both, that is from industry and in academic, will surely will give an more idea about industry 4.0. So for that, I must congratulate all the EEE department staffs and HOD and the management for arranging such a wonderful FDP to the especially young participants like newly joined faculty members. It will be very useful for them. Thank you. Thanks for the opportunity. Thank you very much.
Thank you, sir. Thank you, sir.
Good evening, sir. This is Srinivasan from CK College of Engineering and Technology from Department of EEE. So I would like to first of all thank the management of SMVC for arranging this online FDP session, so which is very useful for us. So I have learned many concepts regarding this, which will be useful for my research work. And also I would like to thank the coordinator of this session and the entire team of this FDP coordinators, because the timely follow-up of the schedule and everything, the information which is passed in the WhatsApp group, everything is nice. So we would like to thank all the entire team of FDP of SMVC, and also I would like to thank the management of SMVC. Thank you, sir.
Any participant want to share your feedback? You are most welcome.
Sir, one small doubt, sir, actually regarding this.
Yes,
So, sir, FDP oral and written, both you have mentioned in the WhatsApp group.
Okay.
So, written means what do you mean to?
We will type the link, sir. That time, and as well as ATAL portal, you need to fill the feedback.
Okay, sir. Okay.
And we will guide you, sir.
Okay, sir. Thank you.
Thank you, sir.
Very good evening, sir. I am Himanshu Tripathi from Ajay Kumar Garg Engineering College, Ghaziabad in Uttar Pradesh. And I joined this FDP, and I would like to thank first Shri Manakula Vinayagar Engineering College and Professor D. Raja, from whom I got the information about this FDP. And I really enjoyed this FDP. It was very well organized, and specifically my area is industry 4.0 and IoT, and I got very useful and very insightful information that what is currently happening and how we can improve or how we can pursue our further research in this area. So thank you all, thank you entire team for conducting such nice and wonderful FDP. Thank you, sir.
Thank you, sir. Thank you so much, sir.
Good evening, sir.
Good evening, sir.
Sir, I am Kadiravan from Rajiv Gandhi Engineering College.
Good evening, sir. Good evening, sir.
Yes. First of all, it was a wonderful FDP to attend. The topic chosen by the FDP was very helpful for understanding the Industry 4.0, the upcoming 5.0. And the experts called for handling the session were highly expertised, and they gave very wonderful data to understand. And the timing and the conduct of the FDP was very wonderful, and very grateful to the whole team behind the FDP. And for me, special thanks to Sivaraj sir for inviting me to attend this FDP. And thanks to Jamuna madam and Raja sir. Thank you. Thank you so much.
Thank you, sir. Thank you, sir.
Good evening.
Good evening, sir.
Ravisharan from Odisha. I would like to express my sincere appreciation to all of you, because I was attending for almost all the sessions except a few minutes, I think. I missed one topic, I think so. I saw that the energy which you have shown, because all the topics were properly aligned, that is more important. The contents are very properly aligned. The sessions were highly informative and insightful, offering the valuable perspectives on particularly key industry trends and emerging technologies. As you all know that we are not studying much about the recent trends. Whenever opportunities are coming, we are reading, particularly for the faculty members. This is very informative, very nice. I congratulate all of you, sir. Thank you.
Thank you, sir. Any other participant wants to share your feedback? Okay, ma'am. Thank you. Any participant want to share your feedback? Sir, ma'am. So please be connected on the line. So we will be having the validity session at 7:30 p.m. And before that, we need to complete 3 tasks as per AICTE guidelines. One is you have to fill the day 6 feedback form, which will be shared now. And then you have to fill the feedback form in the AICTE portal That also we will share how to do it and where you have to find the feedback form. And then at 7 p.m. The test will be enabled. So you have to complete your test before 7:30 or 7:40. So 7 to 7:30 or 7:40 you have to complete your assessment test in ATAL portal. Right? Please feel free to contact us if you have any queries in between that. So kindly stay back and we'll be having the validity session at 7:30 p.m. Thank you. Thank you.
Hello, sir. Good evening, sir.
Sir?
Sir, I'm Dr. Suresh from Vijayawada.
Yes, sir.
As per my previous experience regarding the ATAL portal, it is not possible to open at 7, sir. I think I was attended on FTP in the previous session.
Okay, okay, sir.
There is a website problem, sir.
We tested the participant ID. I think it is showing. We will check, sir. Otherwise, we will do some alternative.
Yeah, yes. Thank you, sir.
Yeah,
So, just I want to inform you regarding.
Thank you so much for your information, sir.
Okay, okay, fine.
Thank you, sir. So, dear sir, ma'am, we will be live. So, to the entire session till the validity session ends at 8 p.m. So, in between that, if you have any queries, you can ask us. We will be guiding you. So, we will be in online only. So, if you have any queries during your assessment, during your feedback filling, so you can raise any queries. So, we will be guiding you. Thank you. Thank you.
Good evening, Raja sir. Hello.
Good evening, ma'am.
Sir, the feedback link for this session, today's session,
Now only we are going to post, ma'am. Now only we are going
on this Zoom meeting only.
Yeah.
Yeah. Okay, sir.
Thank you. Thank you.
Hello. Yes, ma'am. Yes, ma'am.
Sir, good evening, sir. How long the link will be open in the ATAL portal, sir?
Up to 7:40, madam.
7 to 7:40, ma'am.
7 to 7:40. Okay, sir. Thank you.
For assessment, 7 to 7:40, ma'am.
Okay.
Feedback, you can fill it by today.
Pardon?
Feedback, you can fill it, ma'am. For that, we will be having sufficient time.
Okay, okay.
Assessment.
The link will be open till 7:40, right?
7 to 7:40. 7 p.m. to 7:40 p.m.
7:40. Okay, sir. Okay.
Thank
Feedback,
you.
we can fill it later, right?
Yeah, that you can do it later, ma'am. If you are free now, you can do it now. Otherwise,
Yes, sir.
fill it later.
Okay, okay. Okay.
Itself, you try to complete, ma'am. That will help us.
Okay, sir. Okay. Thank you so much. Thank you.
Good evening, Raja sir. I am from Geetam Bhubaneswar, sir, Devashish Ratha. Sir, actually my query is only, sir, fill up the feedback form in this group or, sir, in AIC ATAL portal, sir, AICT ATAL portal.
In chat box, we posted one link, sir. Now,
Okay.
chat box, we posted one link, sir. That is for day 6 feedback link.
Yes. And overall links are given in the AICT portal.
And also you have to fill one more feedback form given by AICT. That is in ATAL portal.
Or two former to be fill up, sir, today.
Regular, every day we used to fill the feedback, sir.
Yes, sir. Yes, sir. Every day. Okay, sir.
On complaint.
Okay, sir.
Yeah. We will be guiding you, sir.
Okay, sir. Thank you, sir. Sir, assessment test question are given in the ATAL portal, the AICT.
Yes, sir.
That portal given. Sir, the time duration is fixed or how much times are for test link activation?
7 to 7:40.
7 to 7:40.
Yes, sir.
Okay, okay.
Portal question enabled at 7 o'clock and it will be ended at 7:40.
Okay, sir.
40 minutes time, sir.
Okay, sir. Okay, sir. Thank you, sir. Nice to meet you, sir.
Thank you, sir. Thank you, sir. Yes, sir.
Sir, I am Dr. Mohan Kumar from Nanda College of Technology, Erode, sir.
Yes, sir.
Sir, really all resource person presentation is incredibly informative, and an industrial person to give such an incredible informative presentation is really excellent, sir. And getting industrial person, that too reputed industries, excellent, sir, excellent coordination. And one more thing, the entire team is sitting in the college and showing their effort, great effort, sir. We enjoy a lot, really, sir. Thank you, sir.
Sir?
Yes, sir.
Sir, feedback in ATAL portal should be filled after the assessment link, sir. After the assessment test.
Yes, sir. Yes, sir. Yes, sir.
Yeah, thank you, sir.
Sir, exam link. Sir, Rajay, sir.
Hello, sir.
Sir, you have to log in ATAL portal, sir.
Sir, I have login, but it is not moving to next. It is just circulating.
Wait for a few minutes, sir.
Raja, sir. Can we start exam, sir?
Yeah, you can start, sir. You can start. In
Okay, okay.
ATAL
Sir?
portal, in ATAL portal, questions are available.
Okay. First, given the test, then after contact you, too, sir.
What, sir?
Sir, exam given in the portal, then after joining in the group, sir.
Yes, sir. Yes, sir. Yes, sir. For validity.
Sir, for validate.
Validity. Validity session.
Okay, okay. So at first given in the AICT portal, the first test. Okay, sir. Okay, sir. Thank you, sir.
Thank you, sir.
Yes, I did answer relative. Sama, betul. Apa ya?
Sir, in ATAL portal it not opened, sir.
Okay, sir. Okay, sir. We will do some alternatives. Sir, Google.
Hello.
Yes, sir.
Sir, we share the Google link, sir, for assessment. Just wait for a few minutes, sir.
Sir, please wait for a few minutes. We will share the link. You can complete your assessment through the link. Dear sir, ma'am, if you face any issue in ATAL portal, you can use the Google form which we shared in the chat box as well as in the WhatsApp group. You can complete the assessment through this Google form. in case if you face any issue in ATAL portal. Kindly join for validity session at 7:40 p.m. Dear sir, ma'am, kindly join for validity session.
You need to all. Dear participants, kindly requested to join quickly. Participants are requested to join for validity session.
Dear sir, ma'am, very good evening to one and all joined here. So we are in ATAL Online 6 Days Faculty Development Program 2024 in 25. In the title Design for Manufacturing and Advanced Automation for Industry 4.0. So we are at the end of the FDP in the validity ceremony. I welcome you all for the validity session. So at this August occasion, I would like to invite our head of the department, Dr. P. Jamuna, Professor and Head Department Dr. P. For the welcome address.
Thank you, sir. Good evening to one and all joining in this validity session. On behalf of the organizing team, it gives me immense pleasure to welcome you all to the validity session of ATAL Online 6-Day Faculty Development Program. The Manakula Vinayak Engineering College was established in the year 1999 with the approval of ACT and Pondicherry University. The institution has 25 years of academic excellence and it is approved by NAC with the A grade for 2 cycles and accredited by NBA in 2 cycles of all the UG and PG programs. It is the first self-financing institution in the country to establish community radio station called Villa CRS 90.4 megahertz to serve for the community. So in this occasion, our college is very proud to organize an AICT Training and Learning Academy sponsored 6-day online FDP program on the topic of Design for Manufacturing and Advanced Automation for Industry 4.0. In this August occasion, I would like to welcome our Chancellor and Chairman and Managing Director, Sri M. Dhanasekaran sir, Secretary, Dr. K. Narayanasamy sir, Treasurer, Sri D. Rajarajan sir, Sri Joint Secretary, Sri S. Velayam sir, Sri Manakula Vinayak Engineering Trust. So, all of your vision, guidance, and expertise have been instrumental in shaping the pathway we step in all success of our institution. Due to the scheduled meeting, they convey the best wishes for the grand success of this FDP program. I sincerely welcome you all, sir. I welcome Dr. V.S.K. Venkatachalamurthy sir, Director cum Principal, Sri Manakula Vinayak Engineering College. Your dynamic ideas are the source of inspiration that propel us towards success. I welcome you, sir. I extend my warm welcome to Dr. S. Jaykumar sir, Controller of Examination, Dr. S. Andumala, Dean Academics, Dr. A. Arivalgar, Dean Academics, Dr. K. Velmurugan, Dean Research and Development, Dr. NSM Kailasam, Placement Officer, Deans of various schools, HODs, and faculty members. All your significant contribution make this institution a nurturing and inspiring place for learning. I welcome you all for this wonderful occasion. I welcome all the participants from various institutions and organizations across India. Over the past 6 days, we had the privilege of exploring cutting-edge technologies, concepts in manufacturing, design, and automation, particularly in the context of Industry 4.0. With the rapid advancements in digital technologies, the integration of smart systems, and the rise of automation, these sessions will have provided a comprehensive understanding of how the manufacturing processes are evolving to meet the demands in the future. Our expert speakers and resource persons have shared their invaluable insights on emerging trends, tools, and best practices that are crucial for enhancing industrial automation and improving manufacturing efficiencies. I would like to extend my heartfelt thanks to the esteemed speakers for their valuable contributions and to all the participants for their enthusiasm, active participation, and engagement throughout the program. As we gather together today to mark the successful completion of this enriching FDP, let us reflect on the knowledge gained, the collaborations fostered, and the vision we share for future advancement in manufacturing and automation. In this occasion, I warmly welcome you all for this validatory session. I welcome you all. Thank you for this opportunity. Thank you.
Thank you, ma'am. Next, I would like to invite Mr. K. Tangaraj, Assistant Professor, Department of EEE, to introduce our beloved Dean Academics, Dr. A. Arivelagar, sir.
Good evening, everyone. It is my great honor and privilege to introduce Dr. A. Arivelagar, sir, who is currently serving as the Dean Academics and IPSC Coordinator in Sri Manakulavinagar Engineering College. With over 3 decades of exemplary experience in both academia and industry, sir has earned a reputation as a respected academic leader and expert in mechanical and industrial engineering. Sir's academic journey is both remarkable and inspiring. He holds a master's degree in energy from the prestigious Pondicherry Engineering College, Pondicherry University, which laid the foundation for his extensive expertise in mechanical engineering, energy management, and innovative technology. His profound knowledge and relentless dedication have helped to shape the future of many students, contributing significantly to the growth of the institution he has been associated with. Sir plays a pivotal role in advancing the institution's academic standards and ensuring quality through strategic leadership and vision. His tenure, which began in July 2022, has seen tremendous progress in academic policies, curriculum development, and overall student success. His experiences also extend to his role as professor and head of the Department of Mechanical Engineering, as well as head of training and placement at GRE Institute of Engineering and Technology. His commitment to research, education, and leadership excellence is evident in every position he has held. He is a true symbol of hope and inspiration for both faculty and students. Now, I request Dr. A. Arivelagar, sir, Dean Academics and IPSC Coordinator, Sri Manakulavinagar Engineering College, to provide presidential address. Welcome you, sir.
Thank you for all your good words. Very happy evening to one and all. At the outset, I thank and appreciate the Department of EEE and the leadership of Dr. Jamuna and Professor Raja and other team members for their excellent way in organizing this 6-day ATAL online faculty development program on the title Design for Manufacturing and Advanced Automation for Industry 4.0. At this juncture, before starting my presidential address, I want to mention a few members who have done an enormous job in this institution. And Dr. E.S.K. Venkarajalpudi, our director, who has got more than 36 years of experience, out of which he spent only 3 years of experience in shaping this institution. And in this institution is 26 years old. And we are celebrating his silver jubilee this year. And we can proudly say he has spent a lot of time and energy in shaping this institution and motivating us to a great heights. I also want to mention one more person, Dr. S. Anbubala, a professor in EEE department and now holding the post of Dean Academics, her contribution is immeasurable. And I also appreciate their efforts on this day. and another gentleman, Dean Research, Dr. Velmurugan, who has been a source of inspiration and support to all the faculty members in bringing out research, publication, and patents. And it's a great pleasure to join in this program for design for and the validation of the design for manufacturing and advanced automation for Industry 4.4. And why this automation or why Industry 4.0 on this occasion has been arranged? Because when we understand the evolution of the humankind, we always understand the human values the time. The human always, the mankind always wanted to reduce the process time. Whether he wanted to protect from the fury of the nature or from the wild animals, if you see the progression or the civilization of the mankind, he was inventing a sharpened stone, then bows and arrows, swords, spears, guns, automated rifles, and it goes on. And same way it can be extended to whether it is an invention of 2G, 3G, 4G or 5G or towards 6G, it all, the mankind is very greedy or ambitious, we can say, it goes for reducing the process time. And as an engineer, we always appreciate the 19th century was a flurry of invention. And in the year when the steam engine was invented, the automation process or what we say industrial revolution has begun. So as a mechanical engineer, I always proudly say, we have played a bigger role. But afterwards, the last years, the last 200 years, the progression has been phenomenal in the area of the computer science and engineering. Please. So wherever it is possible, it becomes our responsibility to reduce the process time, network all the processes, and see that all the processes are getting automated. Or in other words, we want to replace human power. Well, earlier the human power was replaced in the areas where radioactive or hazardous in nature. Now we want to remove. This is what the Industry 4.0 insists upon. Why we have to remove? Because as a matter of, we are very ambitious, the explosion of the population or the increased use of the materials, the luxury, or what we say the increased level of the quality of life, people were using or assuming the Mother Earth is only meant for human beings. No, it is for all the living organisms to coexist. The human mankind cannot exist alone. And this was understood by us, and that's why we started talking about sustainable development goals, where we want to live in harmony with the nature. And if you want to live in harmony with nature, because engineers, we are all passive, we are not active, we introduce all the innovations or invention, and it includes emissions also. We have found out two-wheeler IC engines, or it's an air conditioner, or whatever we say, or even the invention of electricity, it increases the quality of life, but in parallel, we were emitting exhaust to the environment, where we are degrading the environment. And now the two challenges are there before us, the judicious use of the material, and this judicious use of material is very essential to protect for two things. One is how effectively we are going to use the energy, and second thing will be how effectively we are, or judiciously we are going to use the water resources. Because we cannot exhaust all these resources with our generation, and we have to leave pass on this Mother Earth and protect this Mother Earth to our next generations also, how our ancestors have left to us. So that's why we have been including these sustainable development goals in our curriculum and insisting the significance of these SDGs. And because of the explosion of the population, and automatically we go in for judicious use of the material. And if you want to use the judicious use of material, you have to improve the efficiency level of a process. And wherever, if you want to increase the efficiency, we have got no other option but to go for automation. And keeping this in mind, all our engineers are working towards this, how a process, instead of automating a process, how all the process can be integrated, automated. In the place of 3,000 people, either one person can be substituted. This is what the research going on. And few of the European industries have become very successful in implementing with the application of Industry 4.0, where the sensors and machine learning plays a major role. As an engineer, we always insist with our student, the quantification, the ability to measure every parameter is essential. And for this, the mathematical knowledge is the basis, foundation for application of all these artificial intelligence or whatever the discussions we have had so far. From the discussion with the organizing team, I understand several 3 hours program, 2 sessions of 1.5 hours each, 12 programs, 12 sessions have been conducted, whether it's a model-based design approach, human-machine collaboration, automation and robotics, smart design and manufacturing, whatever be the case, and we have to be strong on the mathematics. Only with the mathematics, we can apply the computation process very easier. And as in, because this is being organized by the electrical engineering department, and it's something a feather in the cap, because we are celebrating this era as an artificial intelligence, where a core engineering people have got a big role to play. And with the support of this programming support and all this, we can do wonders. And so as an engineer, we have got the responsibility of protecting our mother earth, and this is the reason behind in organizing this program. I have my congratulations for the entire team, and I have to appreciate all the respected speakers from industries and from reputed educational institutions. We thank with utmost sincerity for involving themselves and enlightening ourselves. And this is a process we have learned, and this cannot stop with this, because this FDP, I feel, definitely has thrown a spark in your mind, and you have to ensure it should grow as in a positive way in search of the knowledge and for future initiatives and partnerships that can drive meaningful progress. I wish every participant a great success, and appreciate one with all the appreciation and thanks to all the speakers, participants, and organizing team. And I think I conclude my speech. Thank you for the opportunity. Thank you.
Thank you, sir. Thank you for your inspiring speech and wishes. Thank you, sir. Next, I would like to invite Dr. D. Sivaraj, Associate Professor, Department of AAA, to summarize the 6-day online ATAL FDP program.
Thank you, sir. So as we summarize this insightful online 6-day faculty development program on designing for manufacturing and advanced automation for Industry 4.0, I would like to take a moment to reflect on the valuable sessions that we have experienced. This FDP was focused on manufacturing and Industry 4.0, particularly the design aspects and advanced automation required for modern manufacturing environments. Over the course of this program, we explored several cutting-edge technologies and methodologies that are driving Industry 4.0 forward. We began with the Session 1 program with model-based design for manufacturing led by Mr. Gautam Rajamohan sir. He walked us through how digital models are revolutionizing the design and development of products, enabling more efficient and error-free manufacturing. And Session 3, led by Dr. Balaji Venkatraman sir, who presented human-machine collaboration, and he emphasized the importance of designing systems where humans and machines work together seamlessly, enhancing both productivity and safety. And Session 4, Dr. Dan Satyaraj sir later introduced us to automation and robotics and advanced manufacturing technologies, particularly 3D printing, CNC machining, and robotics, which are redefining the landscape of modern manufacturing. And the future of Industry 4.0 was further explored by Dr. Bolaji Venkatraman sir. He shared future trends that will shape the evolution of manufacturing industry in coming years. And session 6, we were also introduced to cyber physical system integration by Dr. Ravi S. who have provided insightful on how to advance smart manufacturing systems through effective integration of physical and digital environments. A throughout providing sessions on H2 cloud integration for industrial automation was led by overseas expert Mr. Nandakumar Kandasamy, who explained the protocols and secure communication strategies needed for such complex integrations. We explore the transformative potential of IoT manufacturing as overseas expert by Dr. Hari Prasad Rao Paini demonstrated how leveraging data can lead to smarter, more efficient production process. Artificial intelligence and machine learning industry 4.0 were brilliantly covered by Dr. Pannisalam Ramasamy sir, showcasing how AI and ML will continue to drive automation and intelligent systems in industry. And finally, day 6, Dr. N. Silvanesan sir gave us comprehensive overview of advanced automations, exploring key strategies that allow industry to adapt quickly to changing demands and technologies. Follow that, Dr. Kalacharvi J provided deep insights into quality control assurance, helping understand how we can maintain, enhance the product standards, rapid technology advancement. And the final discussion on Industry 5.0 with Dr. Pannisalam Ramasamy sir has truly paved the way for us to envision a future where manufacturing is driven by not only the automation but also personalization and human-centric technologies. I want to extend my heartfelt thanks to all experts for the time and expertise, as well as the participants for their active engagement through this FDP. Thank you once again. Thank you, sir.
Thank you, sir.
Now I request Dr. D. Raja, Professor, Department of Electrical and Electronics Engineering, to provide vote of thanks.
Thank you, ma'am. Very good evening to one and all joined here. As we come to the close of this enlightening 6 days online ATAL faculty development program on design for manufacturing and advanced automation for Industry 4.0. It is my privilege to deliver the vote of thanks on behalf of my institution, entire management, and director cum principal, sir. First and foremost, I would like to express my sincere gratitude to All India Council for Technical Education, ATAL Academy, for providing us with this platform to organize this online FDP, enabling the exchange of knowledge and fostering growth in cutting-edge fields like Industry 4.0, advanced automation, and manufacturing design. I would like to extend our heartfelt thanks to our distinguished speakers and resource persons from academia and industry, who have generously shared their knowledge and expertise. Your sessions were not only insightful, but also crucial in understanding the evolving industrial landscape, particularly in the era of Industry 4.0. Your contributions have truly made this faculty development program a grand success. I wholeheartedly thank Sri M. Dhanasekaran sir, Chancellor, Tachishila University, and esteemed Chairman and Managing Director, SMB Trust, Secretary Dr. K. Narayanasamy sir, Treasurer Sri D. Rajarajan sir, Joint Secretary Sri S. Velayudhan sir, Sri Manakula Vinayaka Educational Trust for their exemplary support, vision and commitment in all our endeavors to impart quality education and providing support and guidance to complete 1 week online ATAL faculty development program. Thank you all, sir. My heartfelt thanks to our beloved Director cum Principal sir, Dr. B.S. Venkatraman, who is the inspiring source for us to reach the zenith of excellence, and his perfect logistic support makes this event a resounding success. Thank you, sir. I express my heartfelt thanks to Controller of Examination, Dr. S. Jaykumar sir, Dean Academics, Dr. S. Anbumular Madam, Dr. A. Arivalagar sir, Dean Research and Development, Dr. K. Velmurugan sir, Dean Placement, Dr. N.S. Kailasam sir, and other school deans, all the heads of the departments and staffs for their valuable contribution, guidance and encouragement and solemn support shown in all the efforts in organizing this event. Thank you all, sir, madam. A special word of thanks to our head of the department, Dr. P. Jamuna madam, for her support and guidance, and also to the co-coordinator of this faculty development program, Dr. D. Sivaraj sir, associate professor, Department of FDP, and other organizing committee members, Dr. S. Ganesh Kumaran, Mr. B. Parthiban, Mr. S. John Paul, Mr. K. Bangaraj, Mr. J. Muruganagam, Mr. C. Adin Nagam, Mr. Vignesh, Mr. Shivashankar, Mr. Rajavil, Mr. Jnanavil, and Mr. Vasant, System Administrator, and his team for their tireless effort in ensuring the smooth execution of this faculty development program. Your dedication and hard work behind the scene have been invaluable in the successful organization of this FDP. Thank you all, sir, ma'am. I would like to thank our participants from various institutions for their active engagement and enthusiastic involvement throughout this 6 days. Your curiosity, questions, and discussions made this event interactive and productive, creating an excellent learning environment. Lastly, my heartfelt thanks to all those who contributed in any way to make this FDP a grand success. Together, we have all played a part in making this a meaningful experience. As we conclude this program, let us take the learning from these 6 days and apply them to our professional lives, contributing to advancement in the field of manufacturing, automation, and Industry 4.0. Thank you all once again. We hope to see you in future programs. Wishing you success in all your future endeavors. Thank you. Once again, thank you, one and all. Thank you, sir. Thank you, madam.
Thank you, sir. Feel better.
Okay.
Thank you, sign off.
So it's time to sign off. Once again, thank you all.